Everyone, thank you to each and every one of you for joining the Digital Manufacturing Investor Day. My name is Saliq, and I'm a Senior VP within the Industrials M&A team here at BNP Paribas. We're excited to be hosting this virtual event alongside Dyndrite. Before we begin, I would like to note that all attendees are in a listen-only mode. I'd like to remind folks that this webinar is being recorded, and we will share the replay after the event. Following the presentation that we'll be hearing today, there will be a question and answer session. If you have any questions, please submit them in the Q&A chat box. It is now my pleasure to turn the call over to Harshil Goel, the CEO of Dyndrite, to say a few remarks. Harshil?
So thank you all for joining us today. This is a kind of a special event and a very important event to us here at Dyndrite. A number of you may be wondering why we're even throwing the event or what the purpose of this Investor Day is. So to kind of give you kind of a little bit of history and background, back when COVID started, essentially a number of folks pinged me asking me for help or advice in fundraising. And it was primarily because travel was difficult. And so at that time, we kind of conceived of an online event in a completely altruistic manner to help a variety of founders fundraise, network, basically just connect to the financial community. We threw our first event right at the start of COVID. Then a few months later, we kind of threw an encore event because so many people applied and so many folks found value. And quite honestly, so many folks actually ended up raising money. And then as a result of that, BNP approached us, namely Christian, asking to essentially throw a third event tailor it a little bit more towards the later stage companies. So that's kind of the context for why we're here today. The other reason that we're here today was because as we were throwing these events, we kind of discovered that there was an important job that could be done, and that was essentially educating the financial industry, because a number of folks in this industry don't necessarily know what's right or what's wrong in the additive manufacturing space, whether folks are tackling real issues or manufactured issues, or some folks are just simply unaware of how the space operates or are just naive. And the idea of this event was to provide a quick way of getting folks involved, getting folks excited, and starting to kind of dig a little bit deeper into what's going on and why it's going on. Quite frankly, our industry has been stuck in kind of the dark ages for quite some time now. It's only recently that we've been kind of starting to see the light at the end of the tunnel, right? And the digital manufacturing era is on the horizon. This industry has pretty much been in a rut due to a lack of repeatable quality, traceability, machine variability, and honestly, a number of short-sighted folks not solving real issues, right? Like fundamentally, we're also limited by the software because we're also at a kind of a unique point in time where we have a number of machines that are printing much faster than the software can even prepare data for them. So, that's kind of a brief summary, but to kind of help get a better grasp of these issues and educate folks, we have 9 great companies, founders and CEOs sharing their corporate vision, business models, and they're contributing part towards this industry. I'd like to shift gears now a little bit to introduce our key speaker, Klaus Kleinfeld. We invited him to help us understand the dynamics of the industry and a bit of the history by using his wealth of knowledge and experience. Klaus is a founder, international manager, investor, and advisor. He's the chairman and CEO of Constellation Acquisition Corp, a NYSE listed SPAC. Klaus has had a 20-year history with Siemens. He became the CEO of Siemens AG in early 2005 and has successfully led the company through a substantial transformation. With that, I'd like to welcome and invite Klaus.
Very good. My pleasure to be with you today.
Thank you. So, right off the cuff, there's quite a few world events happening at the moment.
Right. You timed it well.
Right. Literally, we were talking a couple of weeks ago and none of this was happening, right? And of course, there are political ramifications, humanitarian ramifications, but there are also, honestly, supply chain ramifications, right? Do you have any comments on kind of what's going on? And it seems like an already stressed system is getting stressed even more.
Yeah, and it's getting stressed and kind of dormant dimensions are getting back into the game. We had already through COVID a stressed supply chain, And now, I mean, geopolitical considerations and national security concerns have come back on. I mean, things that I think many of us, including myself, I mean, who has been born to refugees from East Germany, brought up in the West, and one of my luckiest moments was when I saw the reunification and the wall coming down, and have a lot of friends also over in the East, you know. And I would have thought that this West and East thing is over forever, frankly, you know. And now we're back in that, you know. So we are back in new realities. I agree.
So I mean, even with tragic events, right? There are opportunities, and there are things that are kind of opening up. You know, like as the economy is opening up, even just for example due to COVID, what do you think are kind of the biggest opportunities or challenges that folks are going to have to get over in the manufacturing sector?
I think the biggest issue is what do you choose as a work model for the future? Because in a way, I don't think COVID has brought many new things in, but it has accelerated many of the aspects that have been dormant there. I mean, what we've seen in the whole aspect of online versus physical supplies, you know, and also in the way we work, virtual versus physical. I do believe there's not one answer. I think sometimes these discussions are a little bit too simple because it depends on what industry you're in. You know, I mean, the banks and the financial institutions have all talked about their apprenticeship model, where they want the new crop to look over the backs of the seniors, you know, and I think that is an important point, you know. And then if you go into the manufacturing industry, I mean, we all seem to not remember that in most manufacturing environments, they have been plowing through no matter what COVID was, and have been producing, have been having shifts, you know. And then if you look at the white collar side, I think it's much easier and probably has a productivity advantage to allow more flexibility. I think that's one of the things that we have to figure out, you know, and that's also one of the aspects that people are not taking into account this much. There was, I would say 15 years ago, I mean, a wonderful Fortune article about the question of competitive advantages. And frankly, for those who love to see remote work happening, in a way, they also have to understand that releases the boundaries of physical presence. And that means that the value of work is very different. I mean, you can see that suddenly the option of having a team completely sit outside of the US or outside of their normal territory, you know, and for a long time or almost forever is real, you know. So the competitive environment in the workspace is shifting, and that can be an opportunity, a big opportunity.
I agree. I mean, I'd say as a company that thankfully doesn't necessarily have a large capital footprint, right, we've been able to dramatically change our office space and things because simply, you know, if you're developing software or non-tangible good, right, exactly. You know, you can have a completely different working model, and it opens up the different types of people that you can even hire.
Yeah, exactly. Exactly.
So shifting then gears a little bit, right? You know, additive has been an industry that's been around for 30 plus years, right? And there are clearly some folks who are having some great wins from a production standpoint, but, you know, the overwhelming majority of the industry is not in any production capacity whatsoever. I mean, you've seen a number of different technologies come up, rise and fall, and, you know, take shape. And, you know, what do you think from your experience could be potentially holding this industry back, or maybe ways that this industry could be learning from past folks?
First of all, I have been from the early days on that I saw the capabilities of additive, been extremely interested in it. The reason for it is because that was the time most strongly when I was running Alcoa and splitting into Alcoa and Arconic. And the aerospace sector is a large and important sector, aerospace, defense, and space, a very, very important sector. And that's one of the fields where additive has really a very good chance of adding a lot of value. And the other one is healthcare. You know, so if you want to meet people in your industry, you know, that say, hey, welcome, let's talk. In those industries, they would all want to see you with open arms. The only problem is these are two industries that are highly regulated for the same reasons, and safety reasons. So by definition, progress in these industries is small, but that's been one of the things where people, I think, are saying, my God, why have we not been progressing? But these two industries are the most attractive ones, but they are, unfortunately, because they are regulated, they are slow. The other thing I think that the industry is not seeing clearly enough, and partially because very often the players in the industry don't have an experience with other technologies, and there's this combination, or this competition with the existing manufacturing capabilities, and they very often, for a given product, they are cheaper and faster, and therefore it's hard to make a business case for additive, And the third aspect that I've seen again and again, and I think it's scary, is that the skill set of developers is lagging behind. Even if you talk to a developer and say, I want you to develop a new product or this and that, I think it's way too rare that they think of additive, designing something into additive and breaking the boundaries of how the part has looked before, consolidating parts, even doing mock-ups, in additive. So I think those are things where I would say, if we can look at that, see can the industry educate people more? Can that happen? Can we find combinations of different manufacturing technologies? Where additive is just one element of it. I think this could accelerate it.
I think you bring up a good point, and we've actually talked about this a couple of times, right? The human aspect of this industry, right? Just having even been in this industry just for 5+ years, it's clear to me that the people in this industry are not changing. They're essentially playing musical chairs among each other, right? And without new blood to run the machines, design for the machines, etc., right? The machines themselves ultimately become useless. Right. And it seems like that we're almost a decade behind from an education perspective in getting enough people here, because nearly every company that I've talked to is struggling right now to even hire the people necessary to run these machines. Of course, this type of a problem has existed in the past, right? With any new technology, it takes time for folks to learn how to use it, and disperse that knowledge. Do you know of any techniques or ways that has happened in the past to kind of jumpstart this, or is it just the slow growing university education process?
Yes and no. There's part of it, and there are things that I have seen in those type of highly disruptive things, So let's start with the simple things. I think that potentially a joint initiative, of the players in the advanced manufacturing side. The ecosystem. I'm talking about the ecosystem because in the end, the ecosystem wins or the ecosystem loses. So only after you've done that, you can then go, which company wins and loses, So, but what I would highly recommend is to get more into the universities and also do kind of probably qualification courses, for the existing developers, make them excited, pass out little goodies, that they can use certain tools for free at the beginning, So you basically want to, developers are typically people who have engineering degrees are excited by new things. So it's not difficult to excite them, but I would do more of that. And I know this is very expensive and most companies probably don't have enough means for it. So, if one could have a joint initiative, potentially even with the government. I remember I've been on the Obama advanced industry board, and additive manufacturing already there was a very important part, and I think we even created a center for additive manufacturing. So there are resources, and I think one can pull those off. And the other thing is, when you have something, and that's a more problematic one, when you have something as dramatic as change as this, The issue is, I mean, my old saying says every great idea goes through 3 stages. In the first, I mean, everybody laughs about it. In the second, everybody says it's not doable. And the third, everybody claims that they have had the idea, you know. So it's a bit of the curse of something as dramatic as this, you know. And I would also say, I mean, very often I've seen a mistake being made in general by very strongly technically led, you know, who have a deep network. Some people who have retired, and it's actually not that expensive, you know. And I love this quote, which is actually, I think I forgot who it is from, and it's from basically unweirding the weird. You know, I remember the origin of, and that's a good kind of indicator, the origin of Uber. I mean, the 2 guys, Kalanick and his friend, standing there in Paris in the rain and trying to flag a taxi down, and couldn't get a taxi, you know, and got drenched, and then said, what the hell is that? You know, in a world of today, we're standing here instead of having an app, you know, and this is how Uber was born, and the idea of looking at what we have gotten used to, but what is really not something that we should get used to. And that is particularly in the advanced manufacturing side, so often the case, you know.
No, I 100% agree. 100% agree. I mean, it's gonna take it coming from all angles, and I do like this concept of an industry body or a community, if you will, and basically lowering the bar to entry, right? I mean, that makes a heck of a lot of sense. So in the last few minutes, kind of switching gears once more, a kind of very like more of a financial topic or investor topic, when clearly SPACs had a rise over the last year and have had mixed results over the last year, right? I mean, it's a new capitalization strategy, right? You know, it's clearly different, slightly different to the IPO model. I mean, what's your opinion of the good, the bad, and the ugly of this financing strategy?
And full disclosure, I raised this back together with 2 of my good friends, you know, and last year, and we are currently looking for a partner. And frankly, I would not have done, if you would have asked me about, let's say, 10 years ago, where I was approached, you know, to doing a SPAC, and I looked at that the last time, I would have said, never in my wildest dreams would I ever do that. But the interesting thing, like it is so often in the US, the financial instrument is getting developed, and it has become a really, really cool instrument. I think it's going to stay. And I think you have more voices now than ever that talk about the advantages of the SPAC. And in the end, I mean, it's not that complicated. It's just another way of doing an IPO, you know. But this other way comes with some niceties. Number one, it's faster, you know. Number 2, if you choose the right partner, you know, because you can actually increase your network. I mean, you can basically, I mean, look at, and interestingly, by the way, I mean, we just saw an analysis this week by looking at purely financial SPACs to operator-led SPACs to celebrity-led SPACs, and it's clear the operator-led SPACs have outperformed all the others, you know, and not a surprise to me, because in the end, you know, with an operator-led, you get additional brains, hands, networks, you know. So, but with the wrong, this also goes the other way, you know, if with the wrong partner, you know, who basically wants to just get the IPO done and then jumps into the bushes and disappears, that is usually not a recipe for longer term success. And the other big thing for a nascent industry is that in a SPAC, you are allowed to use forward-looking numbers. So you can talk in the IPO process, you can talk about the future, and your valuation is also more focused on that. At the same time, the market has seen something really good happening from, let's say, last year to this year. The valuations have become much more realistic, you know, much more tied to what a normal investor would look at, like based on cash flow, you know, and not just based on the wildest dreams from 27 to 35 or whatever, you know, with overinflated numbers. And that's also a good thing, because the worst is you go out and you think you had a big success with the IPO, then the market realizes your valuation is too high, you know, and then the stock comes down. From that moment on, you have many, many years of hard work, you know, that you now have to fight an uphill battle. So it's much better to go out in the market because you're also not selling, you know, you're not selling down on the equity. Go out into the market with a realistic valuation, and then have the market form an opinion and say, this is really cool, I want to be in it.
So I think we're at time now in the session. I'd like to open it up for just Q&A from any of the attendees. If you have a question, please supply it into the Q&A section, and I'll make sure to filter and ask Klaus. Please go ahead. And in the absence of immediate questions, maybe I'll ask one question that's been burning on my own head. I mean, clearly the industry has been consolidating as well over the last 2 years. There have been major M&A activity. What areas excite you on that side of things? Like, do you think the industry is going to continue to consolidate? And where do you think is the interesting stuff?
Yeah, I think the industry will consolidate like it is normal in an industry at this early stage, and it's going to help the industry, in my view, done reasonably well. So. By the way, that also raises very often the question, who are the consolidators? And interestingly, it is not the ones who have the best technology, but it's the ones who have the most money, and that's when, by the way, to link it to the previous discussion, that's often when the point comes in, why is it better to be a public company than to be a private company? Because once you are a public company, you obviously have the opportunity to use the toolbox that public companies have in terms of raising money. So, what excites me? The thing that I'm very excited by is the degrees of freedom that advanced manufacturing, some of the advanced manufacturing capabilities have. So I've seen some machines that allow even the use of multiple materials in one piece, and freely using that. Frankly, if you look at which engineer is capable of handling that level of freedom, I think that is the biggest problem. If you have a piece, let's say you do a piece in metal, and you do a piece for space, so where features like weight as well as heat play a major role, this could create enormous value if you can shape the piece with different types while you build it up with different types of metal structure and metal alloys in one piece and get the different capabilities that you need at that position. I think there is no engineer these days who can do it. Because they are already overwhelmed with transferring it into a 3D printed piece, and then if you tell them that's the other level of freedom, they freak out. So I'd love to see more of that, because for this people would pay quite a lot. And the other thing that I would see, which I raised before, and I can't talk about it in too much detail. I invested relatively strongly into advanced manufacturing at Alcoa, and we had, because Alcoa has every manufacturing technology in their skill sets, and the most interesting pieces I have seen that we've made with Advanced were some very large pieces that were done with a combination of different manufacturing technologies. So giving them not just the advantage of being printed, but also giving them the advantage of strength capabilities and weight capabilities, that you would only be able to reach through the combination of different manufacturing technologies. And frankly, the resonance from the customers was insane. Insane. And our manufacturing skills, I think, were at that point in time not at the level that we could have done it at scale, but this is only a question of time, And then the other thing is on the prototyping side. We've done some prototyping with large pieces. I'm talking really large pieces, where we then turned the prototype into a usable prototype, and through multiple, steps, and that's something where the customers just are freaking out, and they are very much paying for this, So those are the things that excite me. And I could go on. There's a couple of other things that excite me when it comes to metals powder. I get very excited because it would also help. It would also help the industry. It would help the regulator to have an easier time of basically signing off on certain parts being made in print.
So we're starting to get some questions in.
Yeah, sure.
This one's from David. So, he asks, what's the greatest bottleneck for AM adoption? Is it the technology? Is it the education? Is it the viable business cases? It seems that you're at least saying for the aerospace and the medical spaces, it's regulation. But for the other ones, maybe, what do you think is the greatest bottleneck?
Well, it's regulation as well as capabilities of developers. Basically, I mean, I would love the discussion when somebody says, I design a new piece. In fact, the real cool thing is not I design a new piece. The moment somebody says, I want this to be printed, that's already when it has gone wrong. You want to talk about the whole structure so that you have an opportunity to use one of the advantages that Advanced has, that you can consolidate. And the moment you can consolidate, let's say 10, 15, 20 pieces, get rid of certain things and basically shave off weight through saving on connectors, shave off weight, through making the structures much more different along the pieces. That's when the advantage comes in. I would love that conversation to happen more. For this to happen, you really do need an educational process on the developer, so that the developer goes back, understanding ideally what the problem of the customer is. And the aerospace is relatively simple. I mean, it's heat, weight, strength, those are the dimensions that, depending on where this piece sits, those are the dimensions. So it's relatively clear to see what is this for this piece, and then for the developer to go back and say, hey, you told me to do this, but I have a better idea. I have the idea of X, When you can do this as a supplier, you are truly delivering customer value, So I wish there were more people there in the development side, who would take that, and also more in the leadership side who would allow them to do it.
Well, I think that's a pretty good question. I segue into the next question, which is, what barriers do you think, like the C-suite face, that prevent them from adopting additive?
Yeah, without being too overly.
I was going to say vision might be one.
Without being too overly critical here, one of the things that always puzzled me when I looked at the backgrounds of the C-suite in the US compared to the background of the C-suite elsewhere, you interestingly don't have that many people who have a technological background. I mean, you see much more often people coming from the financial side or even the legal side. And I think even for those that have a technical background, I mean, it might not be the easiest to get excited over this, and they might say it's too early, I'm not getting into it, But I think one of the issues also is with the industry to explain to be out there, be upfront and say, guys, I mean, this is the value that we can create. But you can only do that if you understand what value is there for the customer. What value is there for, as long as the industry starts talking about this are our skills, we can print this faster, and doesn't translate that into what does that mean for this industry, you'll have a hard time. You have to find somebody, either a customer or do the task yourself, and also talk more about the success stories. There are gazillions of success stories here, even if it's just been a showcase. I would not be shy. I mean, let's just check. I mean, if you even go into an engineering school and say how many people you ask in a room, how many people have seen, use cases, industrial use cases, not just experimental little prints, industrial use cases of advanced manufacturing. How many are this?
Yeah. So we'll ask one more question and then wrap it up. So it seems like you're most excited about metals technologies, right, in the aerospace and medical sector.
Well,
maybe I'm already wrong.
Given that that's my experience background in Advanced, yes, but to get to some of this, you would also need polymers and plastic, So I'm seeing a large field on that, and two different use cases, and for medical, you would also have actually for both sides you would have use cases with different materials, and I love material combinations also.
Okay, well, just to keep things moving along, that's all we have time for at the moment. Kind of a round of applause for Klaus, and thank you for your time. It's much appreciated. With that, I'd like to invite Saliq back to come back on and start the company presentations.
Thanks, Harshil. Klaus, we really appreciate it. A lot of great insights there as well. So without further ado, we'd like to invite Praveen Tummala, the co-founder and COO of Extra 3D. State this again, but right after the presentation, we'll spend a couple of times just going back and forth, having a nice dialogue with you as well. So without further ado, I'll hand it over to Praveen to discuss Extra 3D.
Thank you, Dyndrite and BNP Paribas. Welcome to DMID, and thank you for attending. Since you're here today, I know you believe strongly in the advancement and adoption of AM technologies and the ability for AM technologies to disrupt traditional manufacturing. We at Extra 3D share your belief. Today, I would like to share something extraordinary with you. It's about our company, Extra 3D, and our breakthrough technologies and our products that are set to revolutionize 3D printing. A few highlights about Extra 3D. Extra 3D has a portfolio of 9 key patents and growing. We are a cohesive team of proven AM industry experts and have been working together for the past several years. We boast a combined 50 years of AM industry experience. Extra 3D operates from 2 strategic locations, USA and Italy, with headquarters in USA. While our predecessors made several exponential technology leaps addressing some of the drawbacks of photopolymer 3D printing, the trade-offs between part quality, resolution, print speed, scalability, and accuracy still remain. These trade-offs meant when you optimized some, you had to give up on the others. For the first time, our technologies, highlighted by our hybrid photosynthesis, eliminate the need for trade-offs and optimize all the key competencies independently and simultaneously. As a result, Extra 3D is poised to make a giant leap that will enable far wider adoption of photopolymer-based additive manufacturing. Our HPS is a hybrid light engine solution that offers the combined advantages of 2 light engines, DLP and laser. HPS brilliantly brings together the energy from the 2 light sources and creates a harmonized light engine that unifies every value: wavelength, power, curing time, and simultaneous operation. HPS enables ultra-speed 3D printing at scale while delivering up to 3 times the resolution, Class A surface finish, high precision, and accuracy. Some of our customers spend 30% of their time and resources on smoothening the surfaces of AM parts. As you can see in this video, our HPS technology offers Class A injection molding-like surface finish straight out of the printer. As a result, it eliminates the need for surface finishing processes, which typically are not environment friendly. What about a marketable product that offers our revolutionary HPS technology? It is already here. Extra 3D's first product is an industrial 3D printer named Lumia. It offers resolution that is 2 times higher than standard DLP printers while matching the print speed of the fastest photopolymer printers and offering a larger print area. Lumia also delivers high accuracy and Class A surface quality. But wait, there is more to Lumia. Lumia encompasses other breakthrough technologies from Extra 3D like zero suction effect during the peeling process, non-degenerative wet membrane, and unlimited cross-section printing capability. Now let's talk about print materials. All the standard DLP market materials can be printed using Lumia, so there is no need to develop custom materials. Lumia's revolutionary technologies also enable printing of high-performance materials like ultra-high viscosity resins and graphene nanocomposites. We strongly believe in customer validation of any technologies we develop, so we have involved select customers from the very beginning. Our goal was to understand their needs and how the product should be developed to meet their needs, taking into account capabilities, competencies, and user experiences. Our select customers come from various industry verticals, including dental, automotive, aerospace, consumer goods, industrial equipment, pharmaceutical and analytical equipment. We have set all the critical dates. At present, we are closing our design for manufacturing phase. Our comprehensive beta program covering various industry verticals will launch in June 2022, and we will begin taking pre-orders in October 2022. The full commercial launch of Lumia is scheduled for Q1 of 2023. To summarize, the revolutionary Lumia 3D printer by Axtra 3D is uniquely positioned to transform and expand the 3D printing industry. This unique positioning is evident from the product comparison chart on the screen, which is a plot between print area, resolution, and print speed of various DLP and SLA 3D printers in the market. For the first time ever, Lumia combines the benefits of both DLP and SLA. The transformational result is Lumia is the first 3D printer that eliminates the trade-offs between print area, resolution, print speed, part quality, and accuracy, and offers all of them in one amazing new 3D printer. Thank you.
Great. Thank you, Praveen. Great hearing from you and getting your background of what Axtra 3D does as well. So, a couple of questions that kind of came to mind. The first one being is, you started the company in the midst of the pandemic. So the first one being is, what inspired you, kind of giving your background as well, being in the industry for quite some time, well over a decade, what inspired you to come up with Axtra 3D? And then kind of building upon that as well, what were some of the opportunities or some of the obstacles you kind of came across, just given the fact that you started this in January of 2021?
Thanks, Saliq, and thanks everyone for attending. To answer your question, a lot of our predecessors in the DLP and SLA photopolymer industry have addressed a different problem. No one has taken a serious look at a light engine, which seems to be a drawback as well. On one hand, with DLP, customers typically achieve the speed much faster than SLA. With SLA, we get the part quality and accuracy, right, which is a problem with DLP. So no one has seriously taken a look at the two light engines and said, okay, we have these two choices. There is not a third choice which offers the best of the both. So that's the idea that came to our mind in 2020, evolved into a patent in 2020 that's been filed in 2020, and in January 2021 led to the launch of Axtra 3D. So there's a lot of difficult work that went behind to bring this idea to light, honestly, because it's never an easy task to combine just two light sources. Just combining two lasers is a magnanimous task. Here we're combining a DLP and a laser. So the optics, the optical paths, optoelectronics that were devised behind combining these light sources to bring them so that they operate at the same wavelength, delivering the same power so that they could cure the same material without having to custom develop a material. It was a humongous task as well. All of the challenges really are putting together the two light sources and bringing them together and the optical path that we built behind it. It's probably the biggest challenge, I'd say.
Talk about, no, that's really helpful, and I appreciate that as well. Kind of talk about some of the other elements, right? You talked about the technology, combining both quality and the speed as well, some of the gaps in the overall industry and what some of the other products and solutions are and how you kind of really fit into it. But as you think about leaving a larger entity and you're joining this organization, what are some of the elements of kind of finding the right individuals to be able to join your team, to be able to join the management team, right? Find the folks that have effectively the IT IQ in the industry. Talk a little bit more about that as well.
Yep. The team is the big reason behind the successful launch of the HPS technology. No question about that. For a small team, we have 3 players that are experts in optics and lasers. So they're the primary reason who were able to bring the idea of HPS to life. And we've been working together in past couple of projects as well before Axtra 3D. And the same team came on board Axtra 3D, both from a founder standpoint and also from the founding members.
Perfect. And I've got a question here from someone else on the line. So let me just kind of divert over there. The question is, you mentioned that 30% of the time is spent on post-processing. Can you talk more about this? Why is this the case in SLA DLP?
Yep. No, I have to be clear here. The post-processing is related to surface smoothing after the print process. So we met customers at Formnext and after Formnext as well, and they mentioned that 30% of their time and resources are spent on surface smoothing techniques like post-print surface finishing techniques, not just the post-processing of cleaning the parts and curing the parts. So that is where we make a difference, eliminating the need for surface smoothing or surface finishing at the end of a print.
If I could, just possibly one more question as well, and I like to be cognizant of the time. So having worked as a materials engineer at one of the largest 3D printing companies in the industry, and then kind of moving over and thinking about starting Extra 3D, what were the advantages, you think, of being in a more nimble, faster-moving organization versus having the backbone and the support of a much larger organization that also has the capital that kind of fuel a lot of the projects as well? So if you can talk a little bit more deeply about that, and then how do you juggle all of that? Because it sounds easy the way you say it so far, but I'm sure there's a lot happening in the background.
Yep, very good question. Now, the way things happen at a larger corporation versus a smaller startup like ours are extremely different. Having worked at 3D Systems before, to get some of the approvals, for example, or to get projects lined up and get the projects approved, even though you have an idea, it really has to be tied up to the vision and strategy of the company, right? Whereas at Extra 3D, the vision and strategy are really simple, well-defined, and we're working on one technology, right? We want to take this technology to light and develop applications out of this technology. So it's much easier to move faster at a startup as our focus is limited to one technology or the core technology of the company and the applications that derive out of that. Whereas at a larger corporation, you're probably working on different technologies at the same time, both metals and plastics, or SLA and SLS at the same time, or extrusion and SLS at the same time, etc. Right? So I think it's a day and night difference between the two. I enjoyed both the worlds, I would say. When I first joined at 3D Systems, I pretty much felt like going back to grad school, because it was a highly tech-oriented company, a lot of patents, a lot of research and development going on. And as 3D Systems grew, we started to see more and more of the corporate environment there, right? But coming back to Extra 3D now, it feels more like at grad school as we invented this technology, developed this technology, and now we're starting to create applications and commercialize this technology.
Perfect. Praveen, thank you so much. I really appreciate you talking about the company, answering a few of the questions. Hopefully it was not that painful. So thank you once again. But everyone, without further ado, I'd like to introduce you to Lou Rassey, CEO of Fast Radius. It's a cloud manufacturing company that provides end-to-end solutions for manufacturers. So Lou, would love to kind of hear from you if you have a presentation as well, and then we'll just have a nice little chat right afterwards.
Terrific, Saliq. Thank you. And thanks everyone for participating today. I'm going to go on screen with just a couple of pages here. Okay, terrific. By way of background, Fast Radius is a cloud manufacturing company. We are building a new type of infrastructure to help companies design, make, and move physical products in the digital world. Our product and our platform that we have created is the first of its kind cloud manufacturing platform. I'm excited to tell you about that and what we do at Fast Radius. And I look forward to the discussion, Saliq, with you. The way to think about Fast Radius is we are a software company and we make industrial grade parts. Let's take each of these two in turn. We think of ourselves as a software company. We are powered by software and everything that we do in our factories, in our supply chain, as well as in the customer experience. We are building a suite of tools to support our customers across the journey of designing, making, moving, and managing parts. Those tools include design for manufacturability tools, cost analytics tools, software-driven insights at each stage of the journey. We also provide a software-driven platform for ordering parts when companies need to have their parts made, not just in prototyping, but through volume production. And then when we get into supply chain side of things, we also have a suite of tools where we can help our customers manage their supply chains on an ongoing basis. An example of that is a virtual warehouse tool where we help companies like Airbus create a platform, a virtual warehouse, where they can then order those parts and have them fulfilled at industrial grade standards when and where they need them. And so when we think of cloud manufacturing and us as a software company, we're building out this platform of software-driven tools across the life cycle of designing, making, and moving and managing parts. Like cloud computing, we view cloud manufacturing as a platform where we and third parties can build applications and services over time. Ultimately, today, we make money by making parts for our customers. And so while we're a software company, we also make industrial-grade parts. We use a wide range of technologies, additive manufacturing, CNC machining, injection molding, cast urethane, sheet metal. We focus on commercial scale, parts going into cars, in use in medical devices, in use in volume consumer products. We do work in the prototyping stage too. So we're full lifecycle partners for our customers, but the cloud platform we've built is designed and has been from day one to be something you can rely on for industrial grade ongoing production. We have done work across just about every industry out there: aerospace and defense, automotive, industrial, consumer products, medical, and tech. And our factory network, we make parts in our own factories that we own and operate. We call them micro factories, as well as a network of third-party suppliers that are digitally connected into the work that we do. Our factory in Chicago is deemed by the World Economic Forum to be one of the 9 most advanced factories in the world, implementing Industry 4.0 technologies at real scale. So we're very proud of the distinctive digital manufacturing infrastructure that powers cloud manufacturing. When you think about cloud manufacturing, you can think of it in this tech stack, and we have built out this integrated tech stack, much like you have an integrated tech stack for cloud computing. You have the integrated tech stack for cloud manufacturing. That includes at the bottom the infrastructure of our factories and our supply chain, a learning engine and a digital thread where we can get smarter with every part that we make, software-driven operating system to orchestrate the flow of work in our factories and our supply chain, then the software and services solution that sit on top of that, this application ecosystem where we and third parties can build manufacturing services and software tools using the underlying data and infrastructure. As I mentioned before, we have served thousands of customers across just about every industry out there through the life cycle, making industrial grade parts, powering innovation in the physical world. We've been at this now for 5 years. We're excited to have recently entered the public markets through a de-SPAC transaction. We have a great partnership with UPS, and including a micro factory on their campus in Louisville. Our Net Promoter Score is something we're very proud of. The World Economic Forum recognition, I think, gives an indication of the technical sophistication of the cloud platform. Perhaps most importantly, it's the customers that have put their trust in us to make parts at volume for them and with them as they're bringing innovation into the physical world. But in a nutshell, Saliq, it's a little bit about Fast Radius and what we are building. Excited for the discussion today.
Thank you so much, Lou. Really appreciate it. A couple of basic questions, and I know you and I have kind of talked about this before as well at length, but for the audience, what effectively kind of transpired or what inspired you to come up with Fast Radius? You and your team, I should say.
Yeah, I think it's rooted in the importance of manufacturing and appreciating the importance of manufacturing. This is an industry that really matters in the world. We say it's not just about the things we make, but the things that we make possible. It's not just about the cars, cell phones, satellites, but it's making the world more connected, making the world more healthy, feeding, empowering the world. This is such an important part of how the world works. I'm a third-generation manufacturing guy. I grew up in Detroit. I've been around manufacturing since I was a kid, and I have a deep appreciation for the importance of this industry. At the same time, there are this massive wave of new tools, Industry 4.0 and the innovations around it. So I was at McKinsey for a long time, helped build what is now the Industry 4.0 practice, and saw this wave of innovations coming. New tools of digital design and simulation, new tools in factory equipment and automation, material handling, new models for supply chains. And so it presents this incredible opportunity to create a new platform for how we can design, make, and move things. And given the significance and the importance of the industry, the size of the industry, the wave of innovations coming, it just became very clear that there was an opportunity to create a new type of platform. And we've seen this in other times in the industrial revolutions and generations before. We've also seen it in cloud computing. If you look at the impact of cloud computing as a platform that others can build on, it's driven incredible innovation in the digital world. And we think bringing the digital world and the physical world together in cloud manufacturing creates that same type of market opportunity. And so those were some of the forces as we thought of putting the company together.
No, really, really helpful as well. Kind of sticking with that background that you talked about, right, which is you're a very long tenured McKinsey alum, right? As you had looked at the industry and you looked at its various pain points, you kind of talked about merging both the physical and the logical, physical and the online world, right? What were some of the kind of the pain points that you were witnessing as you were at McKinsey working with some of the clients that really said, hey, you know what, here's a need and no one is solving it. The big guys aren't solving it. I've got the know-how. I've got the right team. Let's embark on this. Can you talk a little bit more about that as well?
Yeah, for sure, Saliq. I think in general, while manufacturing is very data rich, it's insight poor, and the workflows for designing things and making things are still very slow and cumbersome. And information is opaque. It's hard to see what's happening at different stages of the supply chain. And so while the supply chain model created great innovation in the prior century, we don't believe the supply chains of today are meeting the needs of our time. And I think, look, it's in the headlines every day still about how we have supply chain shortages and we're unable to make the things that the world needs where they are needed. And so the pain really is felt in the design stage, in the make stage, and in the supply chain stage. In the design stage, you can't get access to knowledge, access to intelligence about how best to design a product. We are codifying it fast rates, all of that knowledge, putting it in software and making it accessible to anyone with a browser. Then in the make stage, to be able to make the things that you need in a flexible, elastic way, that's not how supply chains were set up. That's very cumbersome, very slow moving, hyper fragmented with subscale shops making the lion's share of components, not using state-of-the-art tools. We're building a state-of-the-art infrastructure to actually then make the parts, and anyone with a browser can access that infrastructure, create elasticity and flexibility in supply chains. And then in the kind of managing the supply chains over time, look, there's just countless parts are sitting on shelves collecting dust, trillions of dollars of just waste and inefficiency in how supply chains are managed. We're creating, and many of our customers use a virtual warehouse, store parts digitally, move parts digitally, and make them only when you need them, and create a much more efficient and much more sustainable, much more carbon mindful supply chain approach. And so I think it's pain across each of those parts of the physical product world that we saw and that we have built cloud manufacturing in our platform to address.
I think what FastRace is doing, and you kind of talking about the supply chain pain points that are out there and your ways to be able to effectively alleviate it, right? I think that's very critical, and it could not have happened in a more time of need for us, right? As we're kind of going through the overall pandemic. So two things happened for you over the last, call it 9 months to a year or so, right? The SPAC portion, that'll be my very last question I'll ask. But how has the pandemic benefited or otherwise helped you kind of engage in more dialogue and conversations, both across verticals you've been playing in, and also opened up opportunities for you in other verticals as well? If you can kind of talk a little bit more, that'd be really impactful.
Yeah, I think a few things. So, like, first, companies are looking for more flexible supply chain models. They're revisiting where things are made and how things are made, and they're looking for modern partners to do that. Where they can engage with them in a digital way and where they can get access to state-of-the-art modern factories that are flexible to serve them. And so we fit that bill. We are a new type of supply chain partner for companies across industries. Secondly, we're bringing new solutions to bear. So we have factories that we own and operate that all of our customers can leverage. We also announced last year a custom microfactory where we have designed a bespoke CNC machining microfactory to meet the needs of one of our industrial customers using state-of-the-art machining and material handling that allows them to have a much more flexible supply chain model supporting the scale-up of a new product that can be copy and pasted as they're scaling their final assembly. And so we are also presenting not just a new supply chain partner, but new supply chain models. through a custom microfactory that they can digitally engage with us on. And that's presenting, great, that there's great interest in the market for that type of solution. And then I think the third thing is the desire for software-driven tools and insights to support the work, whether it's in designing things, the quality management system, the supply chain management systems. People are looking for modern ways of doing work in manufacturing. And we think that's just a wonderful tailwind, this consumerization of B2B or digital coming into manufacturing. And we're so excited. We've just started the out of our customer-facing software tools. But as we look to the years ahead, we just see such demand and interest for new types of software-driven tools to support this work. And the pandemic has, I think, reinforced that as well as companies are looking to get access to data and insight about their supply chains and about how things are made and how they can do that more effectively. So all really powerful tailwinds. And I think the other that I would highlight, Saliq, is the call for more sustainable supply chains. There's just so much waste and inefficiency. Putting parts in shipping containers. We all saw the Suez Canal debacle last year. We still see the problem with the ports every day. And companies are looking for more earth-friendly supply chain models, and that's a big.
So thank you so much, Lou. Two quick questions, if I could, and I promise they're not going to be painful at all. The first one being is, about a year and a half ago, 2 years ago, maybe longer in your mind, as you're thinking about different avenues, strategic avenues for the company, you ended up thinking about the SPAC route. So two-part question there. One of them is, why go SPAC route versus some of the other avenues? And why did you think, now or effectively over last year was the right time?
Yeah, I think a few things. I think for our business, the technology has been built over the last 5 years. We've built that infrastructure that I showed, and it was proven. We have customers that have trusted us across the most demanding industries to leverage cloud manufacturing and making parts for them. So there wasn't about the technology risk. It was now about how we scale. And the de-SPAC process afforded us an opportunity to access the public markets, provide capital to fuel the company's growth. And I think that's was appealing for us about that. And now having closed the transaction, certainly the broad macro market around SPACs is a bit stormy. But we did close our transaction, and we are now off and building. And we're excited about being in the public markets and the opportunities that affords us to continue accessing the capital markets and keep growing. And I think our business is one where we do have a proven flywheel for growth and a technology stack that has been proven and validated. And this was a great pathway for us to fuel the next stage of growth.
Perfect. Thanks. So one real super quick last question that I have for you. What do we expect from you next? You kind of talked about some of the tools and things of that nature you're working on. What can we expect from you next?
I think continued innovation with our customers about how they are using cloud manufacturing to support next generation supply chains. Last year, we announced a number of new solutions that are being built on the platform, including the custom microfactory, including an expanded virtual warehouse model. We're seeing more and more companies adopt these tools for making parts and managing supply chains. And then I think over the next couple of years, we're really excited about the software pathway forward for us. And we'll be talking more about that soon.
Lou, thank you so much for the time today. Really appreciate it. And it's great seeing you.
You too, Saliq. Thanks for having us participate today. Appreciate it.
Great hearing from Lou today from Fast Radius. And without further ado, I'd like to invite Steve from Evolve Additive. Steve is CEO of the company. And again, just to kind of be able to reiterate, we'll hear from the company for the first couple of minutes, and Steve, on the back end, you and I will have just another dialogue as well.
Excellent. Thank you for inviting us. I really appreciate that. And, for Harshil too, for, hosting this from Dyndrite's perspective. I really appreciate the opportunity. And it's great to see you face to face for the first time. I think we've only emailed back and forth or talked on it. It's really nice.
Likewise, absolutely.
And my body's a little older than the picture I put on the screen here, so it is what it is. So thank you again. My name's Steve Chilson, and I'm the founder and CEO of Evolve. And today I'm going to talk to you a little bit about Evolve and who we are, and where we're at in our maturation cycle. So just a little bit about Evolve and who we are. So Evolve is founded in 2017. It's actually 100% focused around production grade additive. So we're not a prototyping company, and none of our solutions or products or applications are focused on prototyping. It was built, the one of a kind product and step technology that we utilize is built for volume and built for production. And when we look at our solutions and the value proposition that it offers, it's all about manufacturing flexibility and creating unique functional products and increased speed to market. So it's doing things that injection molding can't. It's doing things that other traditional manufacturing methodologies can't do. And that's what it was built for from day one. And that was what the STEP technology, which is a proprietary technology, again, was built from day one. So we have a world-class group of individuals that help run the team here at Evolve. We are based out of Minneapolis, Minnesota, but we have another site in Rochester, New York. And pulling together a team like this, where it's the combination of additive and automation, as well now as injection molding expertise around the world, was one of my probably biggest feats, and really enables the technology to do what it can do. And the value proposition that we offer is really about additive manufacturing at production scale. And the big kicker here is without compromise. So we talk a lot about costs and speeds and quality and scalability and materials, and how important that is for our manufacturing customers and application developers. And really the one element we talk about is they're not willing or able to compromise. So again, the STEP technology was created for that alone. Now, the partnerships that we've put together, as again, putting together a system like this in production is not simple, and it can't be done alone. And so putting together the strategic partners that we have, whether it be Materializer or Kodak or Post-Process or Rockwell or B&R, was absolutely essential. Because while the STEP technology is critical to our overall process, one of the things that's very important, and probably more important, is the automation of that process. There was a discussion earlier about repeatability, software, production capability, and that's what automation gives you above and beyond the STEP technology. Now, from an investment perspective, obviously being a younger company and capital equipment company, investors are critical. So we have investors like Lego, Stanley Black & Decker, and 3D Ventures, which we just closed around with in the July timeframe, are actually critical, not just from a capital perspective, but also from the understanding of the market, understanding of, you get a company like Lego or a company like Stanley Black & Decker that are using plastics in the volume they're using it in a very automated way, and wanting to integrate our solutions into their factories, giving us that knowledge and know-how and that voice of customer that's so critical as you launch a company. So it's very exciting to have these groups, not just as customers, but as investors. Now, from our product perspective, we do have an ecosystem that we consider, and we're not just putting out the platform. For us, everything starts with our scalable volume production platform, or SVP for short. But with that, there are the companion products of materials and software and service, and then consulting and application. And the one thing I want to emphasize, materials as we go forward here. And the SVP platform, as I said before, is really built for production from day one. As you can see in the picture here and all of the companion products, this is not a desktop machine by any means. It's built for your factory. The software is built for factory integration, and it's also built for speed and for productivity. So from the efficiency that you're going to get out of a commercial grade production parts out of our system is in the materials that, again, I said materials. And here's why it's so important. Because we offer the razor blade model at volume. So it's really that razor blade model at, I would say, an Uber level. because of our platform is much more similar to injection molding than it is to 3D printing, you can see from the chart here on the right that you're talking about recurring revenues of about 86% of our overall business model perspective, where the system revenue, while nice at 14% overall, is we're really looking at that recurring revenue on the material side that's really driving our business. But you can see, on the chart that we're also offering those products and software and application development. I'll talk a little bit about application development here in a couple of slides, but it's so critical to actually getting the platform off the ground, and that's why we're offering those support services, not just in the machine, but actually helping our customers develop those applications required to get these machines integrated into their factories. And I said it, a couple times, probably ad nauseum here, but it's really important. Materials. In order to get these applications developed, our customers in production aren't willing to bend and yield into similar or like materials. They don't want to hear it's ABS-like. They want to hear it's ABS. They want to hear it's a Saliq ABS or one of the other manufacturers. Same with nylon. They don't want to hear it's this grade of nylon that no one uses. The automotive companies, we know what they want. They want PA6 with glass fill. So that's what we offer, a PA6, so type of material. For us, it's all about our system being able to be compatible with existing injection molding grade materials today, thus putting the onus on us, not on our customer, to make changes. So putting that onus back on us in order to integrate these materials into the overall system and then offer it to them at what we think are competitive pricing for the applications that they're going after. And remember, we're not here to supplant injection molding. Our whole vision is about augmenting, doing those things that injection molding can't do today, whether that be flexibility or part geometry or time to market, or even lightweighting from a sustainability perspective. Lots of many different opportunities because STEP technology and our SVP platform really offers two new distinctive technologies that allow for competitive quality levels. So the STEP technology, there's over 100 patents that define it today, but there are two really distinctive groundbreaking technologies that go along with it that allow us to fulfill our customers' application on the quality side, but also on the productivity side. So as you see, I won't get into too much depth there, but there's one in what we consider to be in situ process control. So the machines really do run themselves on the automation side, and the one technology here on the left is really about we take a topological mapper, we take a picture of every single layer, and we compare that picture to what it should be based on the CAD model. And then we make changes in situ. We make changes based on the realities of inconsistencies, or maybe there's some deformities that are happening because it's real life. We actually correct for that in build, so you're not having to affect or get your overall quality level below where you need it, and also keep that yield up, keep that repeatability to exactly where you want it. The other technology that is on the right here, just quickly, is a smoothing technology, again giving us that injection molding grade quality of our parts. And you can see from this particular picture just some of the examples of some of the different geometries that we can make, but really the quality level that we're getting rivaling that of injection molding. And that was one of our main goals as we started the company. Our addressable market is that, as you would imagine, it really does go wide and deep into whether it be contract manufacturing all the way to automotive. We can address applications in each one of these particular markets. And really, one of the obviously our market, from a financial perspective, our company, our product is all about augmenting that injection molding application and technology and business, and we all know it's about a $300 billion worldwide business. So what we're looking to do is we're looking to grow that, actually take some market share, but it's really about growth. And finally, on this slide here, just kind of showing you our capability versus maybe some of the other additives, but really our benchmark has been injection molding from day one. So our ability to meet costs and speeds and qualities and material types of injection molding has really been our benchmark. So why all the technologies have, absolute application in the world today. I think really highly of all of these other technologies. It's really the Evolve step technology and SVP product that really offers all of these different characteristics, allowing our customers to live and to experience the best world of injection molding and additive, bringing together the quality and cost with the scalability and flexibility of the parts that you can make. It's really a wonderful capability and a really wonderful new, I think, option for our customers to consider as they're looking at producing the products. So just a couple of main takeaways. First of all, for us and all of the work that I've done, I've been in this industry for about 15 years now, a little bit over 15 years. And through my experience, it's all about true industrial applicability. They like to talk about this technology or that, but really for them, in order for you to be considered truly a production grade manufacturing technology, it's really about that industrial applicability. We are a game changer. Our step technology is a great game changer because it is and can do what it can do on the quality side, on the cost side, but then on the scalability side is absolutely a game changer for our customers. And then don't forget the razor blade on steroids really gives us that gigantic annuity stream that allows the company to scale and scale quickly. We are in the commercialization phase and we are scaling up our operations. We shipped our first machine, and we did announce earlier this year an agreement with Fathom, so we'll be shipping our second machine actually in early Q2 this year, and now the scale-up begins. So with that, thank you for your time.
Thank you, Steve. Really appreciate it. Great presentation, by the way. I think there's a lot to take away from it, especially when you kind of talked about materials. We're short on time, so I'm going to ask a couple of questions that I think the attendees are going to be interested in, hopefully. So with that said, as you look at your background right across from Zebra years ago to Dell to Stratasys, if you take the culmination of all of that, what effectively inspired you to say, look, there's a need in the marketplace. This is going to allow me to be the best of the breed and have cutting-edge product solution, the right team. How did you come up with the concept a couple of years ago?
Boy, it's really the culmination of a lot of gray hair. So it's really the culmination of experience both as an engineer, developing product, doing a lot of prototyping, but also, trying to figure out a way how to manufacture product as you're trying to get more and more creative. I think it was in the presentation by Klaus early on. He talked about changing the way people design. And this is what I've been thinking about from day one. Why am I stuck with the rules of injection molding? Why am I stuck with the costs and the 12-week lead times and all of the lack of control once I move the tool to a supplier? So these were the thoughts, going through my head on the application side. Then doing, spending as much time as I have with customers over the years, learning about their pain points, cost, throughput, scalability, materials, all of these type of things, over and over and over again, you hear it from these guys. So on the application side, it was, well, how do you solve these real problems? How do you make something for the customer that really gives them a new way to consider manufacturing? And then my background in printing, because it was about 16 years of printing before I joined Stratasys. And I worked in Stratasys for about 12 years. And it was really the culmination of the laser printing background I have and the thermal printing background that I have, and then tying that together with the 3D printing background that I had, really bringing that together.
The next question I had was, as you kind of think about the various services you provide, one of them being more so on the consulting side. So you're taking a very consultative approach to being able to do advanced manufacturing. Talk a little bit more about that as well, right? Where you're sitting at a table, dining table, wherever it might be. What are those discussions like that enable you and your sales engineers to be able to extract the pain points and then be able to make an effective close? On the other hand, what are some of those pain points that allows you to also go back to the R&D department and say, okay, these are the next generation of best and breed products. and solutions that we should be thinking about?
Yeah, great question. This is really, one of the things I've been thinking about probably top of my head for the last 5 years is about applications and application development. It doesn't matter what company you're sitting at. Name the company anywhere around the world in Additive, and they're talking about the same thing on the application side. How do we build more applications? How do we get more customers utilizing our machines? How do we get more and more, beyond prototyping? How do we do that? And it's funny because you hear it all the time. I've even heard major webinars talking about this, and major players and giant companies, even talking about this. So for me, what I noticed about 3 or 4 years ago, in order for our customers to really accept the new STEP technology, and it's new, right? It's not a derivation of a powder bed fusion or an FDM or an SLS or any of those type of things. It is a brand new technology, and for us to get our customers to adopt it, understand how to use it, and to get the C-suite really to start adopting it, I knew we would need to help them along on the application side, help them build the level of expertise they need on the machine side, but also on the business model side. How do you make these machines more productive? How do you make these machines more profitable on their side? And that's not just going to come by magic. I believe you need to put together a real applications team that can help work side by side with the customers and the clients, so they become clients, not so much customers. And this application effort is really instrumental for us, but I also believe it's instrumental for the industry. I don't believe that there are enough companies out there like Frontier and those type of companies where really they're focusing on application and application development. Be that helping hand for the bigger companies to get over some of the questions about too early, financially not ready. Why? So that's why we put together this really big effort around applications development.
I really do appreciate it. My sincere apologies. We're short on time today for the presentation, but clearly to the audience overall, there's a lot of great things that Steve and the team are working on. There's a lot of data out there. We need to kind of parse through as well. So Steve, you and I will certainly, and Christian as well, will connect with you again. Love to keep learning more about all the great things you and your team are doing. All right, so up next is Sam O'Leary, the CEO of SLM Solutions. And Sam, we're going to stream your presentation here just momentarily. And then just as a reminder, after the culmination of the presentation, you and I will just have a real quick chat, the way you kind of saw Steve and I just did.
Thanks. Great. So thanks, Saliq, and thanks, everybody. I appreciate the opportunity today to talk to you a little bit about SLM Solutions. We're a technology pioneer and innovation leader in the field of selective laser melting, which is the leading metal additive technology. It accounts for about 90% of the global install base of metal additive manufacturing equipment. We're a big player in this market. We have an install base of over 750 very high-value machines currently operational. And we've delivered many of the industry firsts, the first machine to market, the first dual laser to market, and most recently we've delivered a game changer in terms of this technology, and I'll talk a little bit more about that as we get through the presentation. Alongside that, we've got a huge IP portfolio of very relevant patents, and more than 500 of the world's finest engineers in this industry. And perhaps for those of you who are not so familiar with metal additive manufacturing, it's a technology that provides a plethora of hugely impactful benefits. Design freedom. This is essentially giving you complexity for free. And if you have complexity for free in terms of design, that means you get performance enhancement for free. So I think maybe if we can go to the next slide. Alongside that, we think about lead time. One of the great things about metal additive manufacturing, you can really consider new product development, having a version of a new product. Instead of a year for complex products, you can have something within 24 hours. This really changes the way you can think about product development and think about how you manage your design process. In terms of process efficiency, you can operate with zero inventory. So management of working capital and cash conversion cycle is impacted in an extremely positive way. And from a supply chain perspective, very topical, close at the moment, you simply make what you need, when you need it, where you need it. And alongside that, there's huge environmental benefits, not only in not shipping components across the world, but this is a process that produces complex parts with almost zero waste. Moving on to the next slide, Saliq. It's a rapidly growing market. I like all the statements of the people before me. And firstly, think about as this technology develops, we're currently impacting only a very small amount of the traditional manufacturing market. What we're doing with driving this technology and driving the productivity of this market, of this technology, is not just accessing the significant growth that's expected already, but hopefully opening up more of the traditional manufacturing market by bringing technology that has cost parity or even cost benefits over very traditional manufacturing processes, whilst also adding all of the other benefits that I mentioned on the previous slide. So moving on to the next slide, we have already a very huge and impressive install base of more than 750 machines. But what's more important than the number is specifically where those machines are at. Across all industries, the very companies that will drive mass adoption of this technology across civil aviation, defense, space, energy, automotive, medical, and other applications. These are the driving force, and these are people that we've been involved with over many years, enhancing the technology and delivering production applications for our existing fleet. So moving on to the next slide, I mentioned about our history of being a technology pioneer within this industry. We had the first system to market. We were the first with a dual laser system, the first with a quad laser system, and the product that we've just launched a year ago is a 12 laser system. Now, these are not just numbers in terms of the number of lasers that sit within the system. They are exactly the driver around system productivity. And what that gives you is huge benefits in output cost per part. And that is the fundamental enabler to mass adoption. Nobody will ever argue with you that this technology delivers performance enhancement in terms of geometrical design freedom or inventory advantage. The missing piece of the jigsaw has always been cost parity with traditional manufacturing methodologies, and this is really a huge step towards that. So a little bit more detail on the next slide about just what it is. It is purely a game changer. It's bigger than anything else, and it's light years ahead of anything else in terms of productivity. Looking at the next chart, just to give you a little bit of perspective around that, our SLM 500 machine was the most productive machine on the market. Maybe we could move forward one Saliq, please. Was already offering a significant advantage on everything else in the marketplace. But as you can see on the chart on the right-hand side, the NXG is giving a productivity increase of 500% on those already market-leading machines. On top of that, if you compare this to the majority of the single laser install base that is currently operating for production applications with this technology, it's 20 times faster than that. So if you think there was a business case existing for complex components using a machine with one laser that is taking an awful long time to produce components, just think about the impact of 20 times the speed. And along with that, a significant cost reduction in the output per component. Just moving on to the next slide, please, Saliq. We're also enabling customers to do more with enhanced software solutions. FreeFloat is a product that we launched last year. Again, at its fundamental base, it is designed to reduce the cost per part for our customers and enable more application. This is something that we give for free to our customers operating our install base, because quite simply it drives more application, it drives end cost per output down, and of course drives further demand by enabling new application cases. Next slide, just to give a little bit of comparison about what it actually means. everything that we do as a business is focused around enabling our customers to do more and driving the industrialization of this technology. That means everything that we do is focused around open architecture. You saw in the previous slides, our customers are the world's biggest organizations. They're the very people that have been using this technology for a great deal of time. They've developed know-how, and for us, giving them the capability to utilize that know-how, take a base of the technology that we deliver, but fundamentally be able to manipulate that and be able to develop an extra competitive advantage in that industry is something that they consider of great value, and is something that is fundamental to how we think about how we run our business. If you give a customer a black box solution that just says, hey, parameters are fixed, this will give you a good output, but there is no way you can change that, this creates a Me Too situation where everybody can output the same, gives no competitive advantage, and fundamentally inhibits progression and inhibits innovation. So on the next slide, I've got a great advantage of how this performance enhancement of component manifests itself in real life. This is an NXG machine-enabled application for Porsche. It's enabling their EV technology. In its simplest form, it delivers a component that is reduced vastly in terms of weight. It combines multiple components into a single build, a single print. It improves the rigidity of the component by over 100%, and also removed 40 manufacturing process steps. If you think about that in terms of, again, cost and simplicity of process and ability for any factory to be able to produce and deliver this, it is a huge impact. And this is just one example of the thousands of things we see day to day where this technology impacts everything from electric vehicles to rocket engines and everything in between, delivering the capability to make complex parts very quickly, very effectively, and deliver all the advantages that I mentioned earlier. Moving on to the next slide, we are a business that is delivering 2 consecutive years of meeting our guidance, 2 consecutive years of growth in excess of 20%. We've already given guidance for this year of at least 33% growth, and 2026 expected revenue levels of at least 5x what we have delivered in 2021. Alongside that, we have a clear path to break even on a quarterly basis in the second half of this year, and really continue to push forward with the strength of our existing portfolio, with the impact that the NXG is already having in the market. In fact, we just released information today on one of the prominent service bureaus in the industry ordering 2 of these machines to be delivered starting later this year. And finally, on the last slide I've got here is just to show that we're set up for growth with everything in place. We've been building the infrastructure, the people, everything that we need to deliver on this growth. So we have a high operating leverage. The introduction of the NXG and the continued growth across our portfolio will result in a significant EBITDA improvement as we progress through the following months, and of course as our revenue continues to grow through the following reporting periods too. So with that, I hope I've given you a bit of background about who we are and more importantly the direction that we are taking, and I would be very happy to open it up for further questions.
I really appreciate
working for Alstom Power at the time. I think you speak to most people who understand this industry and this technology, they will echo my sentiments that the SLM has always been a technology leader and pioneer within the industry. Going back to 2 years when I joined, what was very clear was the element of industrializing that technology was missing. Running the business properly, developing the products in a way that would meet the requirements of regulated industries. So that is in fact, if you will, the somewhat boring and mundane things that need to happen in the background. Configuration control, developing products based on data, releasing products that are completely tested and understood, that we've got a process that drives consistency from machine to machine. You cannot deliver a machine to a Safran or a Honeywell and have one machine sitting next to the other and having different results coming from both machines. It's having something that is boringly reliable and consistent from machine to machine. And that's what we've focused on as a leadership team. So I've brought in industry experts that come from companies like Boeing, companies like Airbus, companies like Daimler, companies like GE that are familiar with how to develop and industrialize very complex technology. And that is really the missing link. I think that the industry has been crying out for, just give me a product that is boringly reliable and outputs brilliant products in a guaranteed way. And that's exactly what we focus on with the core portfolio and with the new product.
Perfect. Thanks, Sam. I've got two questions that came in as well. So just in the interest of time, I'll turn over to those. First one says is, how have supply chain disruptions affected your ability to deliver or maintain machines in the field?
Yeah, it's a great question, and I would be very happy to sit here and say that it has had zero impact. Looking at this is clearly not the case. Looking at the numbers that we released, the prelim numbers, we've managed to deliver a significant growth in 2021, even given the supply chain constraints. And it's a double-edged sword if you think about it. We have benefited from supply chain issues in that people have accelerated their use and adoption of this technology to solve supply chain problems. But equally, I can then not go back and promise a solution to our customers for their supply chain difficulties and use a global supply chain crisis as an excuse not to deliver. Now, the great thing is we can also produce a lot of the components that we use in our equipment on our own machines, so we can mitigate supply chain issues there. The one area that we have suffered with is the availability of electronics. Up to now, we've managed to mitigate that. It takes an awful lot more of my time than I would like. But it's something that we've been able to manage and mitigate through very difficult actions. I would say in some of our product lines, we've even had to change the configuration based on the availability of controls and electronic equipments. And we've been very dynamic in how we've managed to deal with that to ensure that we can deliver for our customers. So it has been and it is a continued difficulty, but one I think we're navigating well as a business.
Perfect. Thank you, Sam. And just in the interest of time, let me just try to sneak in one more question if I could. Again, this is from one of the attendees as well. It is, you mentioned you were open. Can you tell us about some of the partners that you work with?
We can, and there is this is a huge list that is evolving day by day. So the way I think about this is, we are a developer of the technology, but in order for this technology to be adopted on a completely open and industrial scale, it needs to have an understanding that people in different industries will have different perspectives. They will have different preferences in the type of build preparation software that they will like to use, the type of materials or where they would like to see that material come from, or indeed any other types of software, post-processing equipment. Now, I'm pragmatic enough to tell you that I cannot provide as a business a solution for all of these elements. We need the help of others. And I'm also pragmatic enough that I like to see the market develop in a rapid way. So we offer APIs, for example, to companies like Dyndrite, to Materialize, to Siemens, to comparing with things at the opposite end of the spectrum. We open up, for example, our build plate dimensions, so post-processing companies can go to market and offer solutions that help people in kind of downstream elements of the process chain. We've just announced agreement with distributed manufacturing companies. We've announced agreements for blockchain technology where people can issue build files across the globe without the worry of disclosing IP. So it is very open. We work with material manufacturers. Every single element of what makes an end customer successful with additive manufacturing, we're open to partnership for the benefit of our end customers. And this is, like I say, a huge list and one that is expanding daily for the benefit of our existing and future customers.
Sam, I really do appreciate all the responses, the presentation. Yeah, unfortunately, we're short on time, but would love to kind of reconnect and keep the dialogue going. So, again, we really appreciate you taking the time talking to us about SLM Solutions today.
Thank you, Saliq, and everybody else. Appreciate the opportunity.
Without further ado, I'd like to invite Shri Shetty, the founder and CEO of PrinterPrezz. Shri, will hand it over to you, and we'll spend the back half of the time just having a nice little dialogue.
PrinterPrezz was developed to provide equitable access to life-changing medical devices for the global community, taking premium devices and making them better fitting and affordable for the global market. The global trends are as follows: large aging population globally. Implant companies have historically designed medical devices for the Western population and insurance reimbursement systems. Large populations globally have no access to these devices and are living in pain. Additive manufacturing has extensive benefits in medical devices, as we can closely mimic human bone in terms of structure, stiffness, and shape. The industry is ready for disruptions for the following reasons. AM as a technology has matured significantly and can be used to build regulated parts in volume. Global demographics is driving heavy demand for devices. Healthcare ecosystem is getting more cost sensitive, but medical devices continue to be very expensive. Current medical device manufacturers are not ready for the new reality. PrinterPrezz's proprietary digital backbone can help disrupt cost and performance of premium medical devices, leveraging proven technologies and infrastructure. Medical device innovation includes many steps between development to mass manufacturing. PrinterPrezz has integrated all these steps under our digital backbone. The bottom of our slides show 3 examples across multiple applications: spine, knee, and oncology, and how PrinterPrezz has been able to work with some leading innovation partners to help disrupt time and cost. Our global footprint includes a large innovation center in California, a mass manufacturing facility in Ohio, and a medical device and bacterial testing centers in New Jersey and Boston. We are also looking at replicating our innovation and micro-manufacturing centers across the globe. In the US market, Digital Foundry enables PrinterPrezz to realize higher margins on premium devices. In the Asian market, Digital Foundry enables PrinterPrezz to realize higher margins on premium devices that have been tailored for the local population. The future is engineered materials for medical devices. PrinterPrezz has partnered with Solvay in taking their proprietary materials and significantly increasing its strength. We plan on submitting a line of devices on this proprietary polymeric material to the FDA soon. We have a robust IP platform that is integrating semiconductor-based nanotechnologies on 3D printed devices. These devices are showing significantly higher bone growth and lower bacterial adhesion, as shown on the graphs on the right-hand side. We have a strong cross-functional team across various industry verticals. This includes doctors, medical device specialists, and advanced manufacturing experts. PrinterPrezz closed a $16 million Series A round in 2020 and is currently in the process of raising a $70 million Series B round. This round will be used to expand manufacturing, our product portfolio, and R&D. We have a strong consortium of financial VCs on the left-hand side and strategic VCs on the right-hand side, and are looking for others to join the round. Here is a summary of everything that was discussed in the last few slides.
Thank you, Shri. Really appreciate it. I know the amount of time that we have today is not sufficient to kind of go through and for you to kind of really thoroughly discuss, the inner workings of the company and things of that nature. But a couple of questions. The first one being is, as you kind of think about what PrinterPrezz is doing, right, which is effectively marrying the best of both worlds across medical science and then also advanced manufacturing. Talk a little bit more about that, which is effectively kind of going back to day number one, 4.5 years ago. What did you see in the marketplace that said to you, look, there's a need that needs to be addressed, and let me think about how I can do that, and that's how PrinterPrezz came about. Can you just talk about that day 4 years ago?
Yeah, so basically the medical industry is very unique compared to like aerospace, industrial, and other markets. So one of the big challenges in the medical industry is the fact that the same ecosystem that is used to build aerospace parts or industrial parts are not optimum for the medical devices. It's a well-known fact that there's a large growing medical active aging population out there globally, and there's a lot of demand for medical devices. It's also a well-known fact that orthopedic devices and other industrial devices in the medical space that are created with technologies like additive have much superior patient outcomes compared to a device that's manufactured by traditional manufacturing. The challenges in the ecosystem are as follows. There wasn't a designed end-to-end ecosystem that had everything from design, 3D printing, post-processing, FDA regulation, and all the steps required to take early ideas, concepts, and existing products to market. And that was the gap in the market. A lot of the service bureaus or current manufacturing ecosystems came out of the aerospace and industrial side of the business, and they were designed around those verticals. While medical, there were significant gaps in terms of having an ecosystem where medical devices could be created, which is why PrinterPrezz was formed. PrinterPrezz was formed to combine semiconductor technologies or semiconductor manufacturing backbone with 3D printing and nanotechnology and creating high-end medical devices that could provide devices at the right price and the right fit for the global population.
Actually, really helpful as well. And just on your last comment, talk a little bit more about that, right? Which is, are you manufacturing your own 3D printers? Are you purchasing them? Do you have partners out there that you're actively engaged with? How are you printing these parts?
Okay. So there are multiple technologies that across the last 2 decades, on the printing side and the material side, on the software side, have been developed and qualified for the medical industry. PrinterPrezz is taking these technologies that already have been developed, that have been produced by companies like GE, 3D Systems, EOS, and overlaying them with a semiconductor digital backbone and creating an end-to-end ecosystem to take devices to market faster, at higher yields, lower cost, and better tailored for the patient outcomes. So predominantly what we're doing is we are not creating our own printer. We are not creating our own software. We're not creating our own material. We are taking these pieces of the ecosystem that have already been developed across the last decade, integrating them on our semiconductor digital backbone and using the backbone to create devices that we can take to the FDA. Today, PrinterPrezz has 6 of its own devices that have been completely cleared in the spine space. And in the next year, we are going from spine to extremities to trauma to other areas, and we're expanding the product portfolio from the 6 devices we have today to 20 plus devices that we can take across the US market and the international market out there. But we're not creating a printer, we're not creating a material, we're using already developed technologies out there, overlaying them in our semiconductor digital backbone and integrating them to create high-end products that we own at a price point that is affordable across the globe.
That's really helpful. 2 questions that that immediately kind of comes to mind. So if you're not creating any of these, but you found a way to really speed up that FDA process, how did you come up with that? And what have you been able to do to be able to speed that process up, either from a technology perspective, manufacturing, that allows you to be able to kind of speed up the total market process overall?
Okay. Developing a medical device requires, there are multiple steps in it. There are around 17 to 18 steps in creating a medical device. Today, except for sterilization, all these steps have been integrated inside the PrinterPrezz ecosystem. The fact that within our ecosystem, PrinterPrezz controls the design, the 3D printing, all the steps in the post-processing, all the steps around the instrumentation, validations, the FDA submissions, all under one ecosystem. And the fact that we control the data from early design all the way through mass manufacturing lets us use that data to speed up innovation, create better products, increase yield, reduce cost, and improve fit. That in less than $1 million. So something that typically would take years and tens of millions of dollars, we've been able to cut down time, cost, and price exponentially purely because we control every step in the flow, and we control the data every step in the flow. That lets us design products that are designed for manufacturing. It lets us design products that are designed for cost, and it lets us design products that are designed for customization by different races across the globe.
Medical devices are typically more expensive when compared to traditional manufacturing. How do you scale this down for non-first world countries?
Yes. So if you look at our cost numbers, a typical medical device fully packaged by a competitor or an existing medical device company out there in the orthopedic space costs somewhere between $400 and $700 fully packaged. And these companies sell these devices that typically cost $400 and $700 in a price range of around $3,000 to $5,000 in the end market. By integrating all these steps in our ecosystem and using advanced data technologies, improving yield, and semiconductor processing methodologies, which is very proprietary to PrinterPrezz, we've been able to cut the cost of these devices for a fully packaged device. We've been able to take it from the $600, $650 range down to like sub $100. By doing that, a lot of large markets that historically have been very price sensitive, like Asia, South America, Middle East, and the ambulatory outpatient centers in the US have suddenly opened up to our products because we are able to cut price by a factor of 10 and still have gross margins that are comparable to existing players out there. So if you compare additive with traditional manufacturing in industries like aerospace, space, industrial, etc., because there are large parts, typically additive is more expensive than traditional manufacturing technologies. In our case, because a lot of the parts are smaller, and we control every piece of the ecosystem, and we've taken a lot of the middlemen out of the play, we can actually cut costs down using additive technologies where they are orders of magnitude lower than existing traditionally manufactured parts out there, which has effectively opened up a lot of blue ocean markets out there for us.
Shri, thank you so much for taking the time today, going through the presentation, talk about the company, and then bearing through my questions as well. So really appreciate the time today, and we'll reconnect with you here soon.
Thank you, Saliq.
All right, without further ado, I'd like to invite Adam Hopkins, founder and CEO of Uniformity Labs. And again, Adam, love to hear from you, the background as well about the company. And towards the back half of it, you and I will just kind of reconnect, and we'll go through a couple of questions as well.
All right. Thanks, everyone. So thanks for the introduction, Saliq. And my talk today is going to be about Uniformity Labs, pioneering material technology, enabling digital manufacturing with optimal resource efficiency. Bit of a mouthful, but I'll be able to explain it. So first, 2 seconds about Uniformity Labs. I'll talk more about us later, but we're a materials provider in the AM space and in the broader manufacturing community. So we provide advanced powders that span multiple printers, multiple print processing capabilities, as well as other technologies like metal injection molding and press and center. How do you process materials for cost effectiveness and for reliability? And we focus on enabling production, additive manufacturing at production scales, both from a cost perspective, again, and from a reliability perspective. So with respect to global manufacturing, say more about additive later. We all know there are upheavals in global manufacturing today, supply chains and the like. And there are certain mega trends that have emerged to which additive manufacturing is generally aligned. Lightweighting, of course, critical resource efficiency, using less material, powder instead of machining, which puts a lot of chip on floor. Distributed manufacturing is obvious. Novel materials are possible in AM, but have a way to go. And onshoring, to name a few. And where additive is weak in each of these areas, I'm going to highlight here. So although additive manufacturing is aligned, it's an important trend to enable digital manufacturing in general, there are some problems. So in lightweighting, distributed manufacturing, electrification, printing is just a little bit on the slow side, or old printing, and it's expensive. So it's costly to be broadly deployed. There are ways around that, as Shri was talking about a bit ago, but there are others like Uniformity who are working on those ways. Onshoring, so again, AM is aligned, but scale is hindered. It's expensive to manufacture in large factories in the US. You can't have distributed manufacturing in the US or in this hemisphere, this continent. But you have a lot of footprint if your machines don't produce that many parts relative to their scale. So, if you have a machine about the size of a car or a van, and it's only producing a few tons of finished parts per year, you need quite a number of machines to go to scale manufacturing, to go to hundreds of tons of output. And again, that's expensive. Green production. So AM replaces machining when it does. There's certainly less chip on floor. In the aerospace industry, AM's been adopted broadly or being adopted more broadly for these reasons, for small scale parts or small scale production. But compared to, say, casting, AM requires roughly twice the material. And the reason for this is the inefficiencies in powder production. When you produce powder in virtually any method, grinding, usually atomization for AM, higher quality metal, you only use maybe 40% or 50% of the particle sizes, and the other particle sizes have to go into different processes or have to be scrapped, and they're not premium. And for materials like titaniums and aluminums or tungstens that are critical resources, particularly those titaniums, tungstens or refractive metals, this is a problem, and it's a problem for cost as well, naturally. And it's sort of a hidden secret, right? So your 5-to-1 buy to fly doesn't really go to 1.2 to 1. It really goes to 2.5 to 1 because of these off sizes. So printing is a little bit more green in some cases, but sometimes it's less green because of this powder issue. Then novel materials. In theory, the use of powders as feedstock leaves the door wide open for a wide variety of metal alloys in various printing capacities. But in practice, there's only a small range of easily weldable materials for focusing on printing, laser powder bed fusion, and then easily sinterable materials for binder jetting. They're not the same materials, and that's just sort of a fact of the situation. Right, I'll get back to that in a minute, how Uniformity addresses these issues. But okay, a little bit more about Uniformity. Unlocking AM's full potential. So Uniformity, we sell feedstock materials and engineering software. We address the feedstock questions and we address the software questions. We don't make a printer. We don't do everything, but we focus on some of the most critical aspects, and we work with partners for the others. So we have strong financial backing. So we announced a $40 million raise roughly at the end of late 2020, and broadly patented technology, a bunch of foundational patents across globally that allow us to enable our processing solutions and our material solutions effectively. And these solutions drive value in AM. That's the point. We want to reduce cost, and we want to increase reliability in printing, and that's what we're up to. All right, so how do we do it? A little bit about the technology. Ultra-dense powder is the starting point. So we have different powder recipes for each process and each alloy. And I'll call this our toolkit, our powder toolkit. So instead of just working with the powder we have and suffering the disadvantages of only using 15 to 53 microns and laser powder bed fusion or MEMS grade powder in binder jetting, we rework the powder, we make it denser, we add different sizes and shapes, and we reap enormous benefit from that. We control rheology of the powder, We control, surface properties that allow for better binder absorption and better laser absorption. Our powders are thermally conductive in addition to being denser, and they layer more uniformly, which is a really big deal because printing does need to be absolutely reliable if it's going to scale to medium and large volumes, as opposed to just focusing on small volume parts that are expensive. So there on the right side, you see a standard powder and UL powder. That's the same mass of powder in each of those vials. You can see the UL powder is actually quite a bit denser. So one of the things this enables, and I'll talk a bit more about it in a second, but is with this powder toolkit, we can expand the range of materials that are available for AMS. I put a bullet there about novel sintering materials like AL6061. We've had some public announcements with Desktop Metal on this in the not too far past. All right, so with Uniformity ultra-dense powder that layers uniformly, absorbs laser energy better, we can increase print speeds dramatically in laser powder bed fusion, typically about 3 to 10x once all the benefits of our powder are deployed. And that's with comparable or better mechanical properties than you would achieve otherwise. So you're turning one printer into 3 into 10. That's a vast improvement in customer ROI. And with respect to onshoring, it's a vast reduction in your factory size. This is also true on a bed. This is because parts shrink less when you have to start with. You shrink less linearly. That means you can fit more parts on a bed. You also get much better material properties out the back door. You're not getting 98% dense material. You're getting 99.5. You can reach the quality and reliability and mechanical properties that are achieved in casting, or even more so in machining in certain materials. Degree in production. So we use virtually all of the particles, all the off sizes, as well as the on sizes when we can produce our powder. And that means we get rid of this sort of sneaky back problem of powder production and create a true buy to fly of 1.2 to 1 by using the entire atomizer or ground or grinding distribution or mill distribution. Sure. This is even a bigger deal for materials you can't reatomize once they've been powderized or atomized, specifically powderized, like titaniums, tungstens. It works for aluminums as well. So this makes Uniformity quite a bit greener. It takes an enormous amount of energy to, in addition to being resource efficient, enormous amount of energy to smelt aluminum or to run the Goel process on titanium. And we roughly half that energy and use all that powder and apply it directly to the premium field of AM. The novel materials, just touched on this a minute ago, but this toolkit, this denser powder, different sizes, shapes, controlling the powder allows us to do things that are previously thought to be, I don't want to say undoable specifically, but when you centered 6061 before, you either had Swiss cheese, or which is not usable as a property, or you had cracking, or you couldn't layer your material, and it was known to be very difficult to deploy simply because you couldn't layer it and center it. And, as our press releases have put forward, materials like 6061 and low oxygen Eli grade titanium, we can center these materials to absolute full density, full property. So we introduce, for example, in the binder jetting, the centering space, and the MIM space, far less shrinkage, but also the ability to do medium scale parts, medium size, not just small, but also the ability to work with alloys that are otherwise unworkable. And AL6061, by the way, is the most machined alloy on the planet by a huge margin. So it's a big deal to be able to put into a binder jetting space. So a little bit about our history here, and I won't read through all these bullets. There's some fun items we've printed. Picture of our atomizer pouring molten metal. We actually atomize scrap, another comment on resource efficiency and green capability, and turn it into high quality powder ourselves, as well as mixing. We have pretty substantial capacity deployed now, about 2,000 tons per annum. Right now, last year we shipped about 30 tons. We're planning to ship about 150 tons this year. That's almost a certainty given pre-orders. So we're off to the races. We're in a rapid commercialization stage. We've grown from 12 to 35 people in the last year. We'll be looking to do a Series C round maybe in 6 to 12 months' time, and to continue this approach.
Adam, really appreciate it. That was really insightful, really impactful as well. I think that last slide just as I was looking at it from the employees, all the series work that you've been doing as well, this, I think, probably created 30 other questions for me in my mind. Unfortunately, we only have time to go through a few. So kind of why don't we dial it back to, say, well, let's just go back to 2012, 2011. You're at Princeton. You're working on the PhD. How did all that come together when you work on physical chemistry and this concept of uniformity labs? Why don't we start there?
Sure. Yeah, I'll give you the shortest answer I can to possibly a long question. But I love advanced materials. I've worked in a multitude of advanced materials startups and lead engineering as well as non-technical roles. And there was one of the things that I worked on while with Professor Tal at Princeton was dense packets. So I focused on structural optimization, broadly speaking. That could encompass, photonic integrated circuits or phononics like thermoelectrics or even earthquake mitigation devices. But this technology, after I left Princeton, we had patented a couple items that we were running through, but this technology was imminently commercializable, which I found to be important in the sense that it was not that expensive to deploy. It was in the classical regime instead of the quantum regime. So I went ahead and got together with some other folk, Olet Marani, Jeffrey Goel, and Sal. We founded the company to deploy this technology in additive manufacturing, and we've been developing it ever since.
One of the other CEOs has said this earlier, which is materials. Right. So a couple of things that we hear about quite often here in the industry. One of them is the cost, the speed, and the materials. With that being said, you're looking at an industry that's been around for quite some time. As you were thinking about this, and you're still kind of working on this as well, how are you able to create a point of differentiation between you versus a crowded market? Someone else that kind of comes in, they don't know how one technology differs from the other. How are you able to kind of create that point of differentiation?
Sure. So with respect to our capability, it's platform. So it can be deployed on multiple platforms. We're not a siloed company focusing on one material, and a few of the players in AM are in that world. They're heavily chemistry focused. They've changed some alloy composition. That's a long road to success. What we said is we're going to go after the existing materials, and we're just going to improve them and take that capability and deploy it. And then show the customers the benefits. So we took our dense powder technology, we discerned its benefits, we improved it, we applied it to the technologies that made the most sense in AM, and now we're deploying it from that broad-based perspective. So it's we want to be an all alloy shop. So not maybe not every single one, but we're not going to just apply one item to the stage. Instead, we want to be a major player. As a broad company, and that is different. We also apply our engineering knowledge. It's important to know how to process your material, as you hinted at. So we do spend a lot of the time. We have a lot of engineers and PhDs who work on the processing as well as on the development of the materials themselves. And coupling those two things together gives us an advantage. There are a few people or a few companies that have done both and really focused on it, seeing how to make the most. And there are none that have our, like I called it, our material toolkit to create this ultra dense powder.
Perfect. And then if I could add maybe one or two more questions as well. I'd like to be cognizant of the time, but as you think about building out the overall employee base and the skill sets that they have, what are you doing that's a little bit differently from the folks that you're hiring and their IT IQ versus what you're seeing across the competition as well, right? So before you answer, the way I'm kind of thinking about it is the way that the industry used to be for manufacturing, let's just go back 20, 30 years, right? Because additive manufacturing is not new, but back then the skills that were needed to become successful and commercialize a lot of these products is a little bit different today. Right? And then how do you layer that with the technology and the concept of supply chain issues and onshoring? How do you build all of that to have that bulletproof athletes that are working for you?
Yeah, and so addressing the later question, we don't do it all, right? We don't make a printer, for example, and we're not specific application focused. We have partners who are. Who know what they're doing, and that's important to us. So what we focus on is making sure we serve those channels in this limited framework. The ability, it's limited, but it's the most important one in our mind. And providing the material suitably with a supply chain that's bulletproof. We can use different powders from different suppliers. We don't have to use our own. And this is actually fantastic. If we have problems geopolitically, for example, with one material, we can move to a different supplier. There are many that work in the same. And we can provide, therefore, this type of benefit specific to this powder need and to this processing. Does that answer the question?
It does, definitely. And then one last, if I could, Adam. You talked about closing out Series B. You're embarking on Series C, potentially call over the next 12, 18 months. But so with all that capital, what can we expect from you next?
Sure. So rapid growth is the current story. We're certainly going to have some other new materials coming to bear. So it's that's our business, right? And I think that's just the quick answer, the best way to answer. You'll see more of us.
Perfect. Adam, thank you so much. We really appreciate you asking the question, spending time and kind of telling us about Uniformity Labs today. So thank you once again.
My pleasure.
All right, without further ado, I'd like to invite the co-founder and president of Holo, and it's Arian, and I apologize, Arian, if I get your last name incorrect, but Aghababaie, and please correct me because I know I didn't say that correctly.
No, you did a great job. You did a great job there.
You're overly kind, by the way. So thank you for being here today.
Thank you very much, Saliq. Let me just share my screen. All right. So thanks for that introduction. Great to meet everyone here. My name is Arian Aghababaie, as Saliq said. I'm the co-founder and chief strategy officer at Holo. Excited to talk to you all today about the company and also introduce Pureform to you, which is the first metal AM platform to produce production-ready parts. Just a brief overview of the company itself. We're a top-tier VC-backed startup founded in 2017, spun out of Autodesk. My prior company was acquired by Autodesk in 2014, where we developed the DLP printer, the Ember 3D printer that we launched with Autodesk. And we're backed by VCs such as Lightspeed Ventures, Prelude Ventures, and with strategic investment from Lam Research. And the company was founded to lower the barriers of adoption of metal additive. And we've done that in two important ways. Firstly, we've developed Pureform, which I'll talk to you about today, which is our high-resolution, high-throughput metal AM platform. But we leverage our own technology to service our customers and produce parts for them. And from our San Francisco Bay Area facility here, we have the capacity to produce millions of parts a year. But before I dive into the technology itself, I do want to offer a point of view. And I think we're all here today, especially in the additive industry, because we do have the belief that additive manufacturing has the potential to enable a world that's designed and built without constraints. But it is also true that we exist within a paradigm where the equipment is still expensive, it requires deep process knowledge to operate, and I think as someone mentioned earlier, parts will generally require secondary operations, which is where the vast majority of this cost lies in these parts. In summary, these parts are not production ready. And for widespread adoption, AM does need to match the quality and cost structure, the economics of traditional manufacturing, whilst also enabling the design freedom of additive manufacturing. And that is what Holo was founded to do. And let me show you how we do that. And it starts off with our Pureform process. And the way to look at the screen is really in two halves. On the front end, we have our proprietary platform, which is based on bound metal lithographic printing. And on the back end, we're using standard metal injection molding sintering technology. And if you're not familiar with MIM, just have a look at your iPhone. 7 components within your iPhone is made using MIM. It is a technology that is capable of producing billions of parts a year. But if we just go to the left-hand side of the screen here, what I wanted to point out is two key aspects. Firstly, that we have engineered our own liquid photopolymer resin, and this resin acts as a platform that allows us to print practically any material that can be powderized and sintered. And then we print those in the printers of our own design. These are projector-based systems, which are orders of magnitude lower cost than the prevailing metal additive printers out there. But perhaps more importantly, we're able to leverage projectors to produce multiple parts, anything from 1 to hundreds of parts, simultaneously in a build by exposing 2 million pixels in one go, achieving very high resolution parts, but at very high throughputs. And we're currently working on our next gen system, which will have the capability of producing up to 3,000 cubic centimeters an hour. And the result there is this high fidelity green part that you can see in the middle, which then goes on to be debound and sintered in a traditional method injection molding fashion. And the net result of our capabilities then is kind of shown on this graphic here. And on the x-axis, what I'm showing is feature size capabilities, and on the y-axis, the part volume capabilities. And Pureform is able to traverse a very wide spread of high-resolution parts, all the way from prototype volume, 1Z, 2Zs, up to the hundreds of thousands of components a year, rivaling those kind of entry-level method injection molding type volumes. And not only that, as I alluded to earlier, we do also have a very wide spectrum of materials that we're able to produce. And that is based by and large on the fact that we have a very highly engineered binder system. This is core to our IP as a company, which allows us to produce parts that maintain the bulk properties of the metals or materials that we're printing with. And as I mentioned, it is a platform technology that allows us to produce a wide range of materials, from anything from pure copper, which is where we started as a company. And as most people know, it's a very hard material to produce in additive, all the way through to alloys such as stainless steel, nickel superalloys, and even ceramics on the same printing platform. And the net result of all of that are parts which are very high fidelity, high resolution with fine features and high accuracy, holding tolerances on the order of plus or minus 25 microns, but also very low surface roughness and high quality parts that do not require any secondary operations. And so the parts that you can see here on the screen are examples of ones that we've been servicing customers in the semiconductor industry, HPC cooling, as well as RF, where not only are we producing traditional geometries, but we're imbuing performance with the design freedom that additive offers, such as that cooling plate on the left-hand side of the screen. But also in the medical, dental, industrial, and the scientific equipment industry, we're able to produce parts that come straight out of the furnace and have features such as functional threads down to M1.4, which is a 200 micron pitch, or surface roughness there on the order of 1 micron RA and 50 micron sharp features for biopsy forceps. And so, in summary, as I mentioned at the top of this presentation, the point of view that we have as a company is that we must be able to maintain or at least match the quality of traditional manufacturing and the cost structure of traditional manufacturing in order to attract a wide range of customers. But we also need to then be able to offer up the design freedom that additive manufacturing offers. And we've done that by maintaining the bulk properties of the materials that we print with. We are producing parts with unrivaled resolution and surface finish without the need for secondary operations, which allows us to hit the cost structures required and produce at the throughput needed in order to achieve volume production with additive manufacturing. And to tie it all the way back and to my founding vision of the company, to lower the barriers of adoption for additive manufacturing. Thank you very much. And my email's here on the screen, and I'm sure you can reach out to the folks at Dyndrite to reach out to me if you need to.
And thank you so much. Really appreciate the presentation. With that said, my sincere apologies. I was just informed that we're running a few minutes behind, so we won't have time for the Q&A. But with that said, folks, for the attendees or any of the other panelists as well, if you have any questions for Holo, feel free to reach out to Dyndrite, reach out to the BNP team as well. I will be more than happy to go ahead and relay the questions over as well. Again, my sincere apologies. Looks like we're running a few minutes behind.
No worries.
Next up is from Nexa 3D, Avi Reichental, the co-founder and CEO. And Avi, I apologize that we began a few minutes late as well. Love to hear from you.
Sure. It's good to be here. Let me share my screen. And while I'm doing that, let me offer my congratulations to Arian. From what I just saw, a very impressive presentation. We'll cut to the chase. So Nexa is all about digitizing supply chain. And doing it sustainably. We founded the company about 5.5 years ago, after spending about a decade and a half in additive manufacturing as the CEO of 3D Systems. The need that we saw is, on the one hand, we felt that 3D printing was too slow. We also felt that it was too expensive and not suitable for volume production. And we felt that supply chain was really complex, brittle, and polluting. So we developed a printer that's at orders of magnitude faster, with an open material platform that enables really opening of the aperture for higher functional polymers. We have more than 50 patents, and we're extremely well funded. And the good news is we've been on a tear. We finished the last few years with very high revenue momentum, and I'm happy to say it's continuing this year. We fundamentally have two technologies. We have a photoplastics technology that is LCD light engine based and can print material at a rate of about 8 liters per hour, which is pretty high. And we have a powder bed thermoplastic technology that also can convert and sinter polyamide powders and higher temperature powders at about the same rate. So fundamental to our value proposition is up to about 20x productivity at much larger build volumes. And the good news is we enjoy quite a bit of traction already across the markets that we're targeting, the usual markets that you might expect from a company of our profile. We managed to attract and assemble a group of seasoned industry veterans and innovators, including a great board of directors that goes well beyond just representation of our VCs. And we not only more than doubled revenue year over year the last few years, we also managed to continue to double our team and attract some really awesome talent, even during the Great Resignation. We have a few commercial printers on the market. These are fully featured printers that can print literally in minutes and hours what would otherwise take days and sometimes nearly a week in terms of displacement, with very good accuracy, aspect ratio, and overall mechanical performances at a size and speed that is highly differentiated and valued in the marketplace. That was the industrial printer. We have a similar offering in the dental space that is primarily addressing aligner manufacturers in dental labs, large dental labs. And we have a significant total cost of ownership advantage that starts at about 650%, simply because to match the output of one of our printers, you would need a multitude of, let's say, the best in breed comparables on the market. Taking another slice of a product life cycle, and that will be with also a fully featured industrial strength printer that could literally put in your hands functional materials that you can design with and scale to production in a matter of minutes. We think that that's another very large addressable market. And here again, we believe that we have a significant productivity and total cost of ownership advantage by virtue of our unique light engine technology. We are a polymer pure play additive manufacturing company. We only do polymers. We think that in the manufacturing space, with our speeds and unit costs, we have a shot at going after volume manufacturing. And within that, we target basically the usual verticals that you might expect. We have customer successes in 5 continents and with hundreds of successful installations. We have a global footprint. There isn't a week that goes by that Nexa is not represented or featured through channel partners or ourselves around the world. And we're pretty excited about our growth. This is a high growth and earnings model, which is comprised of hardware, consumable, and software subscriptions, which we expect over the next few years to equal to about 50% of revenue from recurring and over 50% of gross profit margin. We have a very robust printer and material roadmap with the 3 on the left already in commercial status and the 3 on the right coming over the next 8 to 10 weeks. And we feel that we have a significant productivity and technology moat advantage that takes us well into the future. We have a very strong management team. We are continuing to develop now a next generation of polymers, and we have done a great deal through partnerships and collaborations because we think that together everyone wins more. So, for us, COVID has been a good season. The validation of how broken and brittle supply chain we feel is a catalyst for what we do. And personally, 19 years into this, all I can tell you is that there's never been a better time to be in additive, except maybe next year.
I appreciate that, especially how you ended it. I realize that you were incredibly short on time today, so I sincerely appreciate you taking the time for us, going through the presentation, telling us a little bit more about Nexa as well. So for the audience, if you have any questions, feel free to reach out to the Dyndrite team, Christian Hartenberge, or myself. We're more than happy to kind of relay the message and the questions over to Avi. So Avi, thank you once again.
My pleasure, and thank you for including me.
And last but not the least, for the presenting companies, I'd like to invite Tali Rosman, the General Manager and VP of Xerox Additive Solutions. Tali?
Thank you. And thank you guys again for organizing this event. It was great to hear from the different companies. It's always obvious, always a tough act to follow, but we'll try to keep it interesting. So I'm Tali. I'm the General Manager for Xerox SLM Additive, which is Xerox's 3D printing company. And really what we're all about, and that connects to a lot of the themes I heard today, is about driving the supply chain resiliency. We believe that by enabling distributed manufacturing, Lou from Fast Radius was talking before, the microfactory, we believe that the combination of that with the digital warehousing software is the key to supply chain resiliency, which is becoming all the buzz today in investment markets. And, for years, supply chains have been really optimized for cost reduction. And that took a significant toll on companies in the last 2 years. And really, those disruptions have become a new norm, whether if it's COVID, whether if it's ships getting stuck in the Suez Canal, and whether if it's the tensions in Eastern Europe that we're seeing now. All of these put a burden on supply chains, and companies are struggling to get the parts that they need when they need them, which is why you're seeing, 90% of the companies are going to be investing now in supply chain agility. So I think that's really interesting for us as an industry, because additive manufacturing, we all know, has the ability to make parts on demand, which is incredibly well suited to solve today's supply chain challenges. Specifically for us, we're taking this one step further, not just making them on demand, but also making them where you want them in a micro factory, which we believe for that, it has to be easy. So what we're about in Xerox SLM Additive is making it easy to identify the right parts for additive manufacturing, easy to get access to them and make them print ready, easy to make the parts. Easy, we've made LMX, the liquid metal printer we launched last year, is the first time that making production grade metal parts has been made easy, without powders, without toxic risk, without hazardous materials, without shrinkage and warpage and accounting for those, without complex post-processing. We took all the friction off the table to allow customers to get everything that's great about metal additive manufacturing without everything that's challenging about it. That's not all we're doing. We're Xerox, we're a big company. So we launched a liquid metal printer last year. We're launching now the digital manufacturing software platform, and we have a lot more to come. Xerox has a very extensive IP portfolio that's going to ensure our continued growth and investment. And needless to say, I'm not going to repeat stuff that others are saying. This is a very exciting time to be in the additive manufacturing industry. I think everybody's feeling kind of the hype returning and the growth and the interest from customers. I think, the bigger the pain point, the more appetite customers have to try new technologies like additive manufacturing. And the pain point around getting parts has been so significant in the last 2 years that even companies that have been very much on the fence on adopting additive manufacturing, you're seeing that shift. So LMX, production grade metal printing, we use wire instead of powder, which enables us, again, to make it extremely easy to deploy with very minimal facility requirements, very easy to get trained on, very easy to maintain and use. When I say easy and deployable, just to give you the extreme scenario of this, we've been working with the U.S. Navy via the Naval Postgraduate School on helping the Navy with their vision of the floating factory. So really taking the microfactory to the extreme by having 3D printers on ships, making parts on demand in the middle of the ocean. So far we have a printer on land with the Naval Postgraduate School, but now we're actually gearing up later this year to put a printer on a ship and live up to this vision. And, certainly if we can do it at sea, we can do it at land and enable true agility into the supply chain. We're now taking this one step further. We're launching our digital manufacturing software platform. This is, first of all, completely technology agnostic, not just for LMX. It has all the different printers and technologies, particle fusion, binder jet, SLS, SLA, everything that's common in this industry. And essentially it has two parts, the repository, which is kind of the digital warehousing, if you will, and the advisor, which kind of tells you, can I print it? Should I print it? So in the repository, it's like a OneDrive, but for all your parts files, we also have the option to help you populate it. If you only have drawings, we can convert them, et cetera, et cetera. There's different levels of collaboration there, parts that only you can see, parts that everybody can see, and a very intuitive UI. for ease of use and for ease of collaboration. For every part that you upload, we'll tell you two things. Can I print it? Should I print it? Can I print it? What is, just from a manufacturability perspective, parking costs aside for a second, what is the best way to make the part? Best material properties, that is. You can tinker with the scenarios, you can tinker with the material properties, and we look across the gamut of 3D printing technologies there are in the market to tell you what is the best way to make the part from a properties perspective or the properties that you seek. You can actually kind of limit it instead of saying, show me all the different technologies under the sun, show me only the ones I have in-house. So essentially tell me with the equipment I have in-house, can I make this part? The second piece is, should I print it? So what is the economic analysis versus traditional manufacturing? So this is extremely, extremely powerful because today one of the challenges, and we heard this theme throughout the day, is building the business case to move to additive manufacturing. Well, we've made it kind of an instantaneous business case to identify those sweet spots for additive manufacturing in your operation. So again, Xerox LM Additive is all about enabling the supply chain resiliency with the easiest to use production grade metal printer and easy to use end-to-end workflow software. We already got customers, we're already selling, we're out there, and we have a very strong IP portfolio that positions us for future growth. We're headquartered in Cary, North Carolina. We actually have a pretty nice visitor center. So now that COVID seems to be winding down and travels are back, we're happy to have people over. So feel free to connect with me on LinkedIn or otherwise, and we're happy to host you.
Thanks, Tali. Really do appreciate you taking the time and talking about the company and all the great things that you guys are doing. Gals also are doing when it comes to Additive Solutions. So with that said, I apologize again because we're running behind and we're behind on the panel discussion. We won't be able to do the Q&A session today. But with that said, if any of the attendees have any questions for Tali and her team, if you could just relay that over to Christian Hartenberge or myself or to the Dyndrite team, and we'll relay that over to her. So thank you again, Tali. Really do appreciate it.
Thank you.
So without further ado, since we were delayed, I'd like to hand it back over to Harshil Goel to kind of lead us through the panel discussion today. Harshil?
Thank you all for joining for the final panel. I guess since Jeffrey is the only one who hasn't talked yet, maybe we should get his reaction about what you've thought, key things that you think you've learned, or highlights that you think maybe deserve another once-over.
Yeah, interesting to listen to all these presentations. There's some really large tailwinds that we see around application, sustainability, different processes, materials. Of course, I will always bang on about materials with, presently I'm working with Uniformity Labs, but great to see another one of my companies here, PrinterPrezz with Shri. Having that linking to an application is vital, because without the application, there isn't a part or an end product. Some challenges facing us in the future. Absolutely, I think the future is looking very rosy, because I think there's some things happening in the macro side as well as the micro side that really aligns for the acceleration of this technology to scale. Yeah, I think we've proven that the technology is ready in certain applications. Cost is a big issue. There's lots of conversation today around how to bring costs down. And with this, to repeat again, the sustainability thread and certain tailwinds around electrification, where additive can just offer so much to the products. I think it's looking good. Some of the challenges, I think, is how we get it out of the hands of the engineers and into technicians and onto the factory floor. That's vital, so that we're not relying on having PhDs to operate the equipment. No one likes to have PhDs on factory floors. I spent a time at Jabil. We wanted our people to be doing things manufacturing. And I think there's still a question mark over some of the cost structure of the machines and the repeatability of the machines. I think, if you can't have a good repeatable tool, it's very difficult to have a product come off that tool. So that's just a couple of observations. I've been in additive about 10 years now. I'm an investor, entrepreneur, and I've touched software, 3D scanning, and materials now, and applications. And what I always liked are core technology enabling, and then the application. Again, what's the actual part? What's the benefit? So on and so forth of the additive. Anyway, sorry to bang on too much, but I'll pause there and let other people speak.
Well, I'd say the same question would, I guess, go to Tali. I mean, you've been listening to various conversations or talks. I mean, anything that has kind of struck you as new or interesting, or again, would require going back to it again?
Yeah, so first of all, I think there were a lot of interesting nuggets, and I think they're really validating what we're saying, which is companies are becoming more and more open. I was nodding as Jeffrey was speaking because I 100% agree with the points of nobody wants the PhD to do it, so we have to make it easy. So essentially, to make the most out of the potential hockey stick opportunity we have in front of us, we as a community have to collaborate, work together, and make it much easier for users.
Okay. Say, Christian, what are your thoughts on the event? And again, thank you to you for starting and initiating and sponsoring the event as a whole.
Well, thank you, and to you and everybody who has been participating. A tremendous event, and I think, overall, if I had to summarize at the very highest level, what has changed since I started covering the industry, which is I've been covering industrials in general for 20 years, and then I started covering 3D printing 10 years ago, and it's been a sea change since. And that's oftentimes gets lost in the public discussion, but it's nevertheless true. So when you would, walk the halls of the industry events 10 years ago, it was a very different discussion, right? People were fundamentally still questioning the speed and the viability of technologies. Oftentimes, a lot of the machines that were being touted at these events were not actually working. I think we've transcended that part of the discussion, and we've moved on, especially in recent years, to a point where it's a lot more about truly providing holistic solutions to customers. I always like to say, and I didn't come up with it, I don't know who did, but people don't want to get a gadget in a box. They want a holistic solution. And it doesn't start with the box, and it doesn't start with the machine. It starts before that. And I think Sam of SLM Solutions made that point earlier. If you start with the box, then everything else has already gone wrong. And I think we've seen this. We've seen it with each one of the participants at this event. They're coming from a place where it's about providing a true holistic solution to the customer. And they go from there. And I think that will also, and I think we'll probably get to that part of the discussion. I think that will also inform, both going public events, be that by way of IPO and SPAC, but also the consolidation of the industry, which is a lot more, will be a lot more broad-based than just tacking on yet another technology platform, and is going to be more geared towards being more things to more people.
Pulling a question from the Q&A, it looks like there's quite a bit of more enthusiasm now in the additive manufacturing space. Like there was a hype cycle, it lulled out, and it seems like it's kind of coming back. A number of folks seem to be wondering what's causing you to have confidence in this inflection. I mean, Avi, you ended your presentation extremely enthusiastic, so maybe you can take the question first.
Well, maybe that's because I'm an older dog and I've been here a little bit longer. It's my 19th year. I mean, look, every industry goes through a hype cycle as it goes through its digitization phase, and that's why we have hype curves like the Gartner curve that kind of fairly accurately predicts it. I think that the reason that I'm enthusiastic is because I see real demand for complete solutions that are industry and customer friendly, with open platforms and with workflows that are validated and can get to convincing scale consistently. And I think that what some of you said before about the maturity of the industry is true, but we're also in a very interesting convergence cycle of exponential technologies, right? I mean, this is not all about additive. It's about ubiquitous connectivity. It's about infinite computing power in the cloud. It's about chip sensing that allows us to do data acquisition and interrogation in near real time. It's about being able to integrate into more automated workflows. It's about having MES systems in the factory. All of that convergence, in addition to all the heavy lifting that we have done as an industry over the last few decades, and the entrance of, let's say, heavyweight material formulators alongside all of kind of the young upstarts, I think all of that convergence and also the realization of how important it is to have a full solution, including all of the less celebrated parts like post-processing, is what's creating that. And of course, COVID was a fantastic catalyst for our industry in terms of really making supply chain top of mind for every product company.
Just a similar question to you, Shri. I mean, what's giving you the confidence to A, raise a huge sum of money, but B, start this industry as a whole, right? I mean, it seems like your timing was very specific in how you got here and why you're doing what you're doing.
Yeah, so it's, no one has been in the industry as long as Avi has, but I've been here for like 12 years. And if I think about the industry 10, 15 years ago, the core technology demand from the aerospace industry, from customers like GE, or from the medical industry, from customers like Stryker, was already validated almost a decade and a half ago. The challenges were that all the pieces in the ecosystem, the printer, the material, the software, wasn't ready during the first hype cycle, or it wasn't completely evolved in the first hype cycle. In the last decade, between a lot of money getting pushed into the industry and a lot of work being done by different players in the industry, I think a lot of the core technologies like the software, the material, the printer, the post-processing has all evolved to a point where some of the old rules for additive, like additive is more expensive than traditional manufacturing, or additive is only for prototyping, or additive is only a designing tool, is no longer true. The next generation or the next decade of additive is this industrialization. The different pieces in the ecosystem have evolved to a point where they no longer can only be used for prototyping. They can be used to create high volume parts in regulated industries. So the next wave of disruption will be in the industrial automation. It will be in the data piece. It will be in the applications and the end parts that are created on it. So if you look at the companies today compared to companies like 5-6 years ago, 5-6 years ago, you would see, small companies that are making pieces of software, pieces of material, pieces of printers. While today you look at companies that are very evolved and are more industrial in nature than anything that has been in additive for the last couple of decades. I also have a feeling that as we do this transition from low volume prototyping to high volume regulated parts in regulated large industries, a lot of technologies will start translating from parallel industries like semiconductor, like software, where companies like traditional companies that you do not typically think about in the additive space, like the semiconductor companies or Google's or Apple, pieces of industrialization will start transitioning from these far more evolved industries to additive and will start disrupting high volume production across multiple sectors. So it's a very exciting time because I think unlike the first hype cycle where it was application driven but not technology driven, I think the second hype cycle is truly being driven by industrialization of these far evolved technologies. And this includes work done by many, many companies across the last decade. So I think the industry is in a very different place than it was maybe a decade ago.
Makes sense. So switching gears again and asking a question from the chat. Right. There are a number of pieces of CAD, finite element, simulation, topology optimization software out there. And, some of them do or do not, adequately address DFAM or design for additive manufacturing needs. What are your opinions on this type of software, and do you believe it's actually a bottleneck? I mean, if you look at some others, like for example, Benny from Velo, he wants to eliminate all DFAM software altogether by making the machine just better. But I'm curious as to your guys' opinions. Tali, do you want to take a stab at it first?
Yeah, I mean, I think there's two levels, right? One is the existing solutions are too cumbersome for users, so let's make them less cumbersome. And the next step would be, I guess, to Benny's point from Velo, would be, can we just eliminate them altogether? Instead of making the pain point less painful, can we just eliminate it? I really think what's needed at the end of the day, just thinking from a customer perspective, they don't really care about all of our internal issues and all of our formats and all of our needs. They just want an easy solution in their hands to go from, get an optimized design and go from optimized design to having the part in hand as easy, as fast as possible without needing 10 different licenses and switching formats in them.
Avi, you seem to be nodding along. Do you have an opinion?
Well, I have a view, and I think it's closely aligned with Tali's, but I have to kind of back up a little bit. Design for additive goes well beyond machine functionality, and it really it brings in completely new design thinking. It's not just optimization for a specific additive platform. It's optimization for the elimination of design and production constraints. It's it enables combination of parts. It enables lightweighting. It enables the creation of geometries that could not be traditionally manufactured. And I think that it's an important component in the journey of digitizing manufacturing. So I applaud what Benny is trying to do. I completely agree that, as much as we can remove friction from the user experience, it's a big win, and we should open ourselves up to it individually and collectively as an industry. As much as we can also create some uniformity of standards and education, I think we accelerate adoption. But equally, new design thinking that incorporates this elimination of constraints and potentially even other circular economy design principles, I think is a big win for the customer and therefore for the industry.
Yeah, I have a suggestion. Could I put a point in there? I think, as a part manufacturer, I have a different thought process on this. And because I don't come traditionally from the additive industry, I do have a different thought process. Historically, this design for manufacturing, design for additive, has been created in the industry to get a good part or a good-looking part or a high-performing part after the additive step. But as you start manufacturing product in bulk, when you go to the 10,000, 20,000, 30,000, 50,000 orthopedic parts out there, you realize that there are 17 steps after the 3D printing where the end yield, the end cost, the end product performance has nothing to do with design for additive. It's one piece of the whole equation. The industry has to transition from the thought of designing to get a high quality additive part to designing a part that gives you a certain performance in additive, but also gives you certain performance across all the subsequent steps. So the final part that is going in a plane, that is going in a human body, meets the cost and performance requirements that are needed. And that is where, that's a mindset that needs to change as you transition from prototypes that are used after an additive step to parts that start going into regulated industries, because the design is no longer just around additive. It's around additive plus all the subsequent steps after that, which includes sterilization, packaging, testing, everything else. So, As we have evolved in our thought process, as we started transitioning into high volume manufacturing, our design rules, our design ecosystem, our design software in our internal ecosystem has evolved, predominantly driven by data on end yields, end product, end performance, and they're no longer just focused on the additive. And I think that's a transition that every evolved industry will have to do as we go from prototyping to manufacturing.
Jeffrey, do you have a comment on this? Klaus had at the beginning of the conference mentioned that the things that he was the most excited about were these multi-material prints. Yet, I mean, designing for one machine and one process, or designing to meet one engineering objective is hard enough. Designing for new materials or multi-materials is sort of an exponential increase in difficulty, or it's kind of the Wild West from a software standpoint. Do you have any thoughts about this from that standpoint?
So certainly from a design standpoint, and that always interlinks with the materials and the application, because what we want to try and avoid when any engineering designer is sat down coming up with a concept is have to worry about getting it through the process. Yeah, and also they don't want to have to worry about the material properties of the outcome. They want to work within the guidelines. And I've full disclosure, NetFab, which was a 3D printing software company acquired by Autodesk. I ran that in the US 7 or 8 years ago, and from that early experience of the software design aspect, and then spending some time in manufacturing as well for the last 5 years, what my observations are, the design engineers have the tools already they use today. Yeah. And what you don't want to necessarily do is force down tools down their neck they're not familiar with. It's like me with Word and Excel. Yeah. If you want to have faster adoption, you integrate into the tool and workflow, as well as the MES system, which is another big. You extend design software into software generally. Don't try and push something onto a big customer that's already doing it in a particular way. Otherwise, you're going to just have resistance. So that's my view on the software. To accelerate additive in these places, you got to use the tools that they're used to. I think from both a design and manufacturing standpoint, I think you can aid them with additional tools, absolutely, but that's just going to take more education. With regard to multi-material, absolutely, everyone wants that. Who doesn't? But again, you've got to have it you've got to be able to qualify that process and ensure the mechanics are repeatable. Otherwise, it's not a manufacturing process; it's a prototyping tool. So that's my observation on those two components.
So then, maybe switching gears then to kind of a more financial or investors centric conversation. We talked about M&A earlier, right? Avi, you've acquired yourself a number of companies over the years, right? How do you see the M&A landscape evolving over the next 2 to 3 years, and how much more consolidation do you expect?
Well, look, it depends on the objective of the acquirer, right? I mean, in my mind, you have to kind of look at, are you a company that has the skill and the ability to integrate businesses effectively, and are you buying complementary force multipliers that allows you to expand your addressable market in ways that can be meaningful to your customers and to your investors over time? Are you buying revenue? And are you really good at it? And how much can you acquire in any given season, right? That's one part of it. The other is where are we in the cycle in terms of technology and business maturity, and who's viewing it, as threatening and competitive, who's viewing it as an advantage, who needs to be acquired, and who can go it alone. All these factors enter into it. Another way to look at it is to ask yourself, can industry, even at its inflection point now, support so many players in certain segments of the market, and will it sustain itself, or will there be some self-selection? And that's a part of it as well. For companies that get into a certain scale and have the access to market, have the channels, and can access customers and markets more easily than companies that only are in the technology stage, oftentimes an acquisition makes sense. But you have to be very deliberate and very focused, and you have to kind of know how to do it and how to integrate it and not get ahead of yourself.
Really, I think the market would welcome and needs is additive on an M&A front getting involved in non-additive. Yeah, so some transactions are not AM to AM. AM businesses buying an AM business, a AM business buying a non-AM business, which already has customers, processes, so on and so forth, and revenue, because I think that's often what's missing with a lot of AM businesses is revenue and critical mass. Yeah, and then bringing the AM through that process. So an established company, deep roots into its customer base with a defined process, and the additive can go in through a more trusted model. Classic example, if we're 3D printing material company perhaps, and maybe we go and buy non-AM material companies, or in a medical implant, you go and buy non-AM implant companies, and so on and so forth. So I think those sorts of strategies are going to be interesting, because there's a lot of pressure on revenue growth, and it doesn't have to always be additive. Additive will come, it takes time, it's growing fast, but we all know that investors are not necessarily patient, and investors punish management teams, and they punish those companies who don't deliver on their revenue forecast and promises.
Because I agree with you. I think to call a spade, we all know most companies in our industry are not yet profitable.
Mm-hmm.
They're the big ones. We're publicly traded. You can see most of them are losing money, which means most of them are going to need to be raising money next year, 2 years. And I think the capital markets, even though our industry is growing and on the up and up, capital markets are going into more of a bearish mode. And I think fundraising is going to be harder in 2022 than it was in 2021, which I think will push some of the smaller players into consolidation. So I think we're going to be seeing more of that.
If I may just offer up a point here, and I concur with everything that's been said, but I think in addition to that, there are a few hurdles that were in existence, 5 years ago, that have been removed and will open the spigots for new M&A. And I think one of those, is the fact that industry, consolidation from inside the industry for the longest time was not possible, because a lot of the companies in the industry, the pure plays, did not really have the firepower nor the attention or the luxury of paying attention to M&A that was needed. That has that hurdle has certainly been removed. You've seen this with both established 3D printing companies that have been public players for a long time, and publicly listed companies. And you've seen it obviously with the rise of SPACs that are very generous sometimes in using both their cash and their public market currency to deploy that towards M&A. I think it's the worst kept secret in the industry that consolidation is long overdue. You have a massive amount of R&D and SG&A and other redundancies between companies that are inefficiencies, right? And these inefficiencies should be removed. The other thing I will say here is that larger companies that got involved in M&A a few years ago, it was a mixed bag, right? And I think for that reason, a lot of them, stayed away for some time. And I sense that is something, that sentiment is sort of a shift as well. And the last thing I will say here is 10 years ago, a lot of people thought that M&A was a good idea, right? And building broader portfolios with more capabilities was a good idea. there was a time when people had concluded that that was wrong. I personally do not believe that that was actually wrong. Timing sometimes plays a role, right? And those people who actually had this idea of consolidating the industry were actually not wrong. They were in many ways ahead of time. And that we've seen that in other industries. And unfortunately, the reality is that the so-called, if you want to call it Me Too's that sort of embark on the same strategy just 5 or 10 years later, sometimes they are the successful ones. Harshil, to your point, I think you said the industry is there's a lot of musical chairs going on and being played in the industry, and I think from that standpoint, a lot of the same people are still around and have maybe not even learned their lessons, but understand that they had the right ideas, just maybe at the wrong time. So I think, again, to me, the bottom line here is that, yes, consolidation, I think, will play a massive role for the sector going forward.
I think that's an interesting point, but to kind of tie it to what Tali just said, right? There are a number of companies, both public and private, who are barely even breaking even or operating at a loss, right? So on one side, we have companies that are not necessarily doing so hot in the eyes of the financial industry. On the other side, we have these extremely long timelines to actually deliver anything, simply because the buy cycle for any of the people using these machines, because they're making physical goods, is so long. And then on the other side, we have an industry of folks there are just too many of any specific type of company, and there's redundant R&D. Right, like for example, there's, I think, in our database over 90 photopolymer machine manufacturers on the planet. Right, there's no way that all of them are going to succeed. Right, but with the mixture of all of this, if the market is trying to consolidate, but none of the people who are bigger or have enough money to help consolidate, what's the end result here? Right, like it seems like there's sort of a catch-22 situation happening.
I have a different perspective to that. So if you look at 10 years ago, at the startups that were out there, they were more evolutionary than trying to make a big difference, like trying to disrupt markets. So if you look at them, they would make a photopolymeric machine, which is slightly better than the previous one, which is why they could get to market faster, they could get to revenue faster, they could do a lot of things a lot faster because they take something and make it slightly better. Across the industry, if you look and see, the quality and caliber of startups today in the additive industry compared to like a decade ago is very different. And everyone are trying to make a big difference. Let it be binder jetting, let it be the software side, let it be the hardware side. There's no longer, there are a lot of companies that made those evolutionary changes. Now, if you have to make a difference, you have to make a big change. That's why a lot of these companies are going in big with a lot of money. And it's taking them longer to get to market and create revenues and all the traditional metrics that we use, because the kind of changes that they're trying to make towards industrialization is a lot more challenging, a lot more bigger in terms of impact compared to what a startup would do like 10 years ago in the same industry. I think M&A back then was also much smaller and was predominantly product driven. M&A going forward will be towards industrialization and, will be driven towards applications more than actually evolving products. That's just my personal view. But I think the kind of talent that is coming into the industry from other industries, the kind of startups that are coming out there, they're trying to make big impacts, but on the flip side, it takes them longer to get to market, generate revenue, and all the traditional metrics that we've used historically to raise money. And they need to raise a lot more money to make the impact. But I think it's just part of industry evolution, right? If you look at the battery industry 10 years ago, the kind of companies that were there back then in batteries versus the kind of companies that are today in the battery industry are very different. And they're trying to make an impact at a scale which is much bigger than some of the traditional startups have tried to do in the space.
Slightly different lens on this, specifically on your comments, Harshil. The world doesn't need 90 photopolymer companies, and reshuffling the deck and changing the ownership of these 90 companies that you have in your database is not going to alter their trajectory. There might be 5 or 6 really valuable technologies and assets within that in the right hands, their potential could be unleashed and there could be a big win. But when you get to a situation that you have so much crowding in certain spaces, M&A doesn't solve, all the problems. And some of these will sadly self-extinguish because of what I'm saying. And the good ones will either make it on their own or will benefit, and there'll be a tremendous force multiplier from a combination, because in many instances there is the redundancy of not so much the R&D and the SG&A, but the phase of scaling an early stage company to a significant go-to-market, the ability to open channels and have access and play where you need to play is where a great deal of inefficiency exists as well.
I agree with you, Avi, and that's honestly where I was heading, right? It's not like one company is going to buy the other 89, right? Or some oligopoly is going to happen, right? It's truly, with sadness and, some usefulness, a number of these have to extinguish in some way, shape, or form, right? And so, the question then becomes for the investment community, well, which ones truly deserve to rise up and which ones are going to self-extinguish? And I think that's one of the reasons why a number of the attendees we have here today are kind of attending. All right. So I guess continuing onwards, with regards to the new SPACs that are coming out and where things are going, right? I mean, we have two folks, right? Namely you, Avi, Shri, and I guess also Joffrey, right? I mean, you guys could theoretically go the SPAC route, or you could go the traditional route. Out of pure curiosity, where's your head at with regards to these things? Is this even a trajectory you're considering, given everything you've seen so far, or are you on to something new or different?
Speaking for ourselves, these SPACs have been around for donkey years. We used to call them cat shells in London 20 years ago, when I was doing them. Then it's cheap access. It's cheap access to capital, not from a cost standpoint, but easy to get is probably a better expression, because you've got to just persuade some people who may or may not be intelligent about the particular area. It's very interesting what Klaus said around an operational management versus a celebrity management. It makes a lot of sense, doesn't it? You don't bring the Kardashians into an additive play. From my perspective,
who knows? Because some of them own multi-billion-dollar companies. I mean, I'm not sick. That makes logical sense.
Maybe they will help to open the door, and that's what you need is the network. So if they've got the right network and you're doing cosmetic additive business, I think it aligns quite nicely there. But if you're doing something selling to spaceships, it's probably less relevant. But they might know Elon. I don't know. So, joking aside, any CEO and any exec team and investors got to be careful where they go get their money from, and there's different routes. It's a less transparent route, optics to the company to use a SPAC. Personally, I'm not close to the idea in any company that I'm involved with, but if it's the best way to go, you go that way. If not, you do an IPO. Or the other way is reverse onto the market through, acquiring something similar. From my experience in finance, I've been in and around financial markets, like a lot of folks on this call for couple of decades, and things go through phases, and there's full circles, and what might be in flavor next year may not be what's in flavor this year. What all companies need is access to capital, strong balance sheet to grow. And what's great about being public is being able to have that tool set to go and do some innovative financing as well as M&A with shares, so on and so forth. So always a place for them. How you get on, it depends on which way the wind's going on that particular quarter that you're going into the market.
Yeah, my perspective is, almost a decade and a half ago, I was part of a company that went down the IPO route, went on the public markets, and It got sold subsequently, but there are pros and cons to the public route. Being a public company is good because you don't have to be in, as a startup, you do not have to be in this constant loop of raising money. But the flip side is you are a public company. So you have to be there is a whole bunch of headache that comes with it. The pros of the SPAC market is that, it's given access to a lot of capital to a lot of companies that have disruptive technologies out there. And hopefully the right team with the right technology, with the right amount of money can disrupt the industry faster than something a traditional company out there could do. So giving money to startups, either through the venture route or the SPAC route, makes sense because, that's the only way to accelerate disruption across many, many verticals. And, a lot of different governments across the world have done that, and it's been very successful for them. The flip side is it's this challenge of being a public company and having the right expectations, both from the investors and the street. So I think there's a fine balance out there on when you go IPO versus when you raise investor money, how much money you raise on an IPO, and what they expect, as long as the expectations are set correctly. And I think, that is where, like Jeffrey said, SPACs have been around for a long time and they're not going away. I just think, they will, we've seen a hype cycle, and there will be a mode where there will be a little more control around how we project, how much money we raise. And, it may not be a $2 billion valuation, but, it may be a valuation that gives you enough capital to disrupt the industry, right? And everything tends to balance itself out. And, I think companies, the question is not, is it good or bad? The question is, when is the right time to raise money through these different channels, and how mature are companies to be in the private markets or to be in the public markets? And I don't think there's any right answer to it. It's purely dependent from company to company and where they are in their growth and evolution cycle and how much capital they need.
Yeah, let me offer a slightly different view here. First, you need to be ready to be public. How you get public, depends on what's available, and there is in essence a cost penalty to doing it one way or the other, from a SPAC to doing a traditional IPO. But first and foremost, you have to be ready, both in terms of your scalability and sustainability and ability to print good quarters, once you go public. And we will see more of it in the coming seasons as a few more companies in our space will go public, and we will also have the benefit of seeing what happened to the new class of publicly traded companies that became public largely via SPAC mergers, but not solely via SPAC mergers, and you begin to see kind of a tale of two cities, right? I mean, companies that were ready and earned the right to be public will kind of ride with the public equities cycles, and whatever happens, in those cycles, they'll be within plus or minus, something depending on their unique position. Companies that are not ready have already experienced significant compression in their valuations, and they probably did it because at that point in time it was the best liquidity event for them to do. So they did it. They got the liquidity event. They got some cash. If you look at redemption rates now in SPACs, they're kind of in the 90s. When this journey started for Additive, it was in single digit. On the flip side of all of that, there are hundreds of SPACs that are hunting for targets, and they have about a 2-year shelf life with a 6-month extension possibly, and so there'll be more deals out there. But at the end of the day, the name of the game for good companies is not to get to that liquidity event, but what to do, with access to public equity once you have it. In other words, you don't make the mark when you do this. The more meaningful part of your journey just begins. And having been on both sides, that I can tell you from experience, because I think in my journey I did more than 40 earnings calls, so I got to experience it, to its fullest extent. Yeah.
To add to what Avi just said, which I think is very, very, very important here. First of all, there's no question. SPACs are here to stay, right? I think they've proven their value to the market, and in a way, they're almost like the most extreme form of raising money in the public market, because they're disproportionately deferential to value discovery in the public market. There is, as you know, there's no traditional book building exercise. It is really deferential to the public market, and the public market can be erratic or volatile or whatnot, and the swings can be extreme, especially with smaller companies. That said, and there's very good evidence out there in the form of studies, that what has happened to SPACs is only to a smaller extent due to macro concerns or macro issues. It has to do largely with how the particular companies perform and how they deliver on their expectations. And the reality is that north of 80%, I think, is the number of the companies who went public by way of SPAC have underperformed expectations. So we should not really be surprised by the compression in valuations. And like Avi said, I think the upside for those that actually make good on their promise is substantial. The other thing I will say here is to maybe tie the two themes together. Just like with private companies, also with public companies, there will be a weeding out of those who are not viable public companies. Maybe the public market is usually very good about that, and for those companies, the M&A door will be open as well. And I think that was maybe the third hurdle that I wasn't referring to earlier that has been removed. Right, once you put a public mark on a company, and once there is a traded security, M&A is a lot easier all of a sudden. So I think those themes are all work together.
And I agree with Avi in that you don't raise an IPO or a SPAC to cash out and leave. You raise it to begin the next major part of your journey. So okay, but we're definitely coming up on time here. I wanted to thank all of our panelists personally. Thank you, Tali, Shri, Jeffrey, and Avi, for your time today. I'm sure the folks who've been listening have been excited to hear what you have to say and your perspective. Thank you, Christian and BNP, also for hosting and sponsoring the event. And with that, I'm going to turn it over to Christian for some final concluding remarks. Thank you all.
Well, thank you, Harshil. So first, I wanted to thank Dyndrite and the entire team, you, Harshil, and Sean and Hafsa and everybody else on your side for all the good work, for the opportunity to host this event alongside you. Dyndrite has, as we think, become a true thought leader in additive and in digital manufacturing, first and foremost by the solutions they're offering on the software side, but then also, as Harshil pointed out, by really providing these forums in a way that few other companies do, where they really open up the discussion to industry participants, be those competitors or just other people, other travelers on this road. So thank you again for the opportunity. I think we heard today from a wide range of companies across the spectrum of digital manufacturing activities. I have myself been covering the additive manufacturing industry for over a decade now, and the developments that have been unfolding over the past 2 to 3 years are truly a revolution within a revolution. Advanced manufacturing has evolved from a hardware-centric to a solutions concept, which is a hallmark really of successful commercial ideas across the board in history, or at least in manufacturing. companies are not trying anymore to sell you a box. They listen, they learn, they provide solutions to your problems, and we've hopefully all been able to witness that today. As that revolution within a revolution continues, we will see the promise of additive and digital manufacturing being fulfilled. And all things take time, and I think we're at the precipice of that trend. BNP Paribas prides itself, that is actually our motto, of being the bank for tomorrow. And there is, in my view, no sector that epitomizes this quest more than advanced manufacturing. So we're proud and excited to support companies that create sustainable manufacturing solutions for tomorrow's world. And again, thank you everybody for the hard work and for your time. And with that, we conclude this session.